Today, I'd like to share with you three
Hello. Hello, everyone. I'm just going to turn this off for a moment. So, trying something new here. We're trying to do some streaming of math and AI and programming and whatever I get up to. Today's just a test stream. So, we are testing audio, we're testing the video, and testing this computer. So first off, let's see if my audio is correct. Seems a little hot. Yeah, there's a lot of background noise, isn't there? Okay, let's see what I can do about that. Audio input. Properties. Right. We're going to monitor it. Okay. Yeah, there is quite a bit. So I'm just going to turn down the gain like this. Okay, let's try that. Is it too quiet now? Let's see. Seems a little quiet now. You know, the other option is I could turn off some fans and cook in this room. Let's see. There's a perfect point in this gain. I like that, where my voice peaks pretty high, but looks like the noise floor is a lot lower. Alright, let's try that for now. Okay. So, quick overview of the channel, just so that I can practice doing this. Welcome to Average Expectations. I need to turn off the audio monitoring. One sec. It's very annoying listening to your own voice echoing. Okay, great. I'll turn back on the background music. I just turned it off for a sec. How's that? Check, check. How's my voice now? Okay. The music's a bit of a work in progress too, so we'll see whether we stick with relaxing jazz or what. Okay, we're gonna turn this down. How's that? Too much? Okay. I did turn it down. I can barely hear it now. Check, check, testing. How's my levels now? There are. I'm splitting the hairs on this player. Okay, so I'm at minus 40 decibels. Minus 35. How's that? I really should write these settings down. You know, let's just stick a little section down here. Even higher, okay. Just setting things up. I mean, that's what this stream is for. How's that? We're going to write down these levels. So my voice is sitting around minus 10 decibels at the peak. And the desktop audio, which is just the background music right now, is sitting at minus 25 right now. So it's a little too high. We'll bring that down. Same for 30. So it's peaking around 30. And this is the desktop background music. Okay. How's that? We're sitting around -30 right now. Liked -35. Okay, so we're going to go down a hair more. I think that's a little lower. Yeah, that's a little lower. Okay. Sometimes, you know, it's like in science, to repeat something, you have to write it down, you know. I don't know who said it, but, right, XKCD said this. They said, science is just when you try things, but you write them down. So, we've written this down. Hopefully next time that means I can do this without spending 5 minutes testing. Okay. Well, I don't hear any complaints from the peanut gallery, so we're going to get started. Welcome to Average Expectations. The channel name is a bit of a stats joke. And what I do here is I'm going to do projects that involve AI, programming, math, gaming, music, and just whatever strikes my fancy. Now, my schedule is going to be Fridays, every Friday night, hopefully. And if there are any exceptions, I will post something. Channel rules, very simple. Oh, that's my wife in chat. Big shout out to you for helping me out, both with the stream setup and also with all this gear. I've got a pretty amazing rig here that I'm working with. It's good both for streaming and also for running various deep learning models, because it's got a big honkin' GPU in it, and that's part of what we'll be doing today. I'll get back to that after we jump into the actual project. So let's see. So channel rules, very basic stuff. Please be respectful and civil. Do not harass people. Do not solicit. So post links to things for profit. Do not spam, and please don't post personal information. The only thing I'm posting is my name, and yeah, otherwise keep your private lives to yourselves. For course-specific stuff, because I am TAing a course, if you need to contact me, use the official methods, but if you also want me to read it faster, you could ping me in chat, although it's not required. Okay, so as far as projects go, let's see. So today, I'm going to try to rerun a really old deepfake that I generated of Leonard Cohen's voice. It's not a very good deepfake. Actually, it's terrible. But, you know, this channel is called Average Expectations, not Great Expectations. So, you know, you get what you pay for. And then in the future, I've got a couple other music-themed projects, mostly because I have some composition stuff that I need to get around to, which these projects will help support. And then after that, we'll get into more of the gaming side. We'll see. I mean, all of this is kind of up for grabs right now. So let's jump right into today's project. And because I am an academic, we are going to be doing a lot of PowerPoint-style presentations, just because that's what I'm used to. And hopefully it doesn't come across too much as a terribly boring lecture. Hopefully it comes across as a mildly entertaining lecture. But the basic idea here is we are going to try to replicate Leonard Cohen. His face is right here. And his sound, and turn it into some kind of robotic, like, I guess it's a bastardization, really. That's the only fair way to explain it. So, why Leonard Cohen? That's a great question, and you should know the answer to that specifically. But anyway, I will talk about that. So, here's the agenda. We are going to test audio. Oops. Done! We figured that out. Test moderation. I think we will be able to do that later, or in progress, we'll say. Okay, and then as far as the actual project goes, we're going to try to get things running. And then depending on how that goes, let's say it's successful, we can play around with it a bit. If it's totally crash and burn and everything fails for some reason, then I will just go over some of the materials I prepared with this project back when I did it, because I ended up presenting it for a course as a final project. So present all the things. Okay, so that's the agenda. Let's jump right in. So the first thing is, why Leonard Cohen? So to tell the story of this funny thing, we have to go back about 5+ years. So a number of years ago, I was traveling through, I think I was visiting people in China, family and relatives, and I remember some momentous thing happening in the news around 2016, and it really made me think, there's a song to be written here, and whose voice better to present this than Leonard Cohen? I was gonna put sexy, but let's just stick to something PC. And because he speaks truth to power. And if you know what happened in 2016, you can kind of get an idea of that. But anyway, we are not going to discuss politics here. The point is that I had an idea for a song, and it kind of percolated. And keep in mind, back then I was not I wasn't doing anything related to machine learning or AI or math. I was teaching music. And so this idea stuck in my head for a while. And then a couple years ago, this was 2020? Yeah, it was around 2020. I thought, hey, this song is finished. I finished the song somewhere around that time. And then I'm like, who would be nice to have as a vocalist for this song? Well, Leonard Cohen. So at that point, I was studying in my second undergrad in math and stats. So I thought, what better time to try to use some deep learning and bring him back from the dead? Because in case you didn't know, he passed away a couple years ago. Actually, let's find out when. (2016), yeah, so around that same time. Anyway, so that's kind of the background. And so now, let's talk about how this works. So, back then I knew almost nothing about these kinds of models, but I did know that GANs could do amazing things. So I thought, so what is a GAN first off? It's a generative adversarial network. And if you're studying deep learning, these things are pretty familiar by now. They're all over the place. And so some amazing examples that you can find include things like creating music from scratch, creating images from scratch, mostly images. You can do a lot. You can create text, although nowadays we mostly use transformers. So GANs are a little bit out of date in some areas, but still very useful in others. So what does it do? Well, basically, it has to, you have a source and a target, and it tries to make the source sound like the target. And it does this using a discriminator and a generator. So you can think of the generator as the student, and the discriminator is the teacher. And the teacher... here's a question. Why did I teach myself these models at the time, or was I already familiar with GANs before I started? So at the time I knew what GANs were, and I had, basically had read about them. and I had never actually done anything with them. And for this particular project, I basically swiped again from the internet, and then I tried to contort it into a shape that would work. And I'll go into how I did that very shortly, because that's necessary to make this work. Yeah, but the basic idea is that you have this student, and then this teacher. Really, it's more of a grader. It's not really teaching the student. It's just telling it whether it's right or wrong, you know, much like an Asian parent would. So the idea is that based on the feedback that the generator gets, it tries to make things harder for the discriminator to tell apart. So the discriminator is basically trying to tell apart the source and the target, and the more the generator sounds like or looks like the target, the harder it is for the discriminator to figure this out. So the better the generator is doing. And when you actually use these things, you really only care about the generator part, right? That's the part I wanted. But oh, I forgot to add one point here. Okay, so let's talk about how this whole thing works. First of all, I had a whole presentation that goes over the kind of more theoretical details. So we're just gonna skip over that because I need to get it working on this machine, and that's kind of my next goal here. So let's talk about practical stuff. So let's see. There's really a number of parts because I cobbled this thing together using, you know, a complete mess, like a Frankenstein of various pieces. It's really confusing, and if I had to do this project again, I would not do it in this kind of convoluted way. But the first thing we have is some kind of sound, so let's create a little sound here. There is my sound. And we'll give it a nice pretty color like that. Yeah, nice. Okay, so here's your sound, your input audio. Right, and the idea is that we need to turn it into some other audio. And the reason why I chose to do it this way is because I wanted control over the performance that I was getting. So basically, there's a lot of speech synthesis kinds of programs out there. So the idea is you type in some text, right, and it goes through this synthesizer and it creates audio. But the problem with that is you don't get any control over when things happen or how it sounds, right? So if you think about the way somebody sings, they're going to be very controlled about when words happen and also how they speak those words. And so what I really wanted was like a style transfer where I keep the exact performance, but I just make the voice sound more like somebody else, right? So in this case, what we have is kind of this audio to audio pipeline. So let's do that. And we'll give Leonard a different color here, like that, right? And in the middle, we're going to need some kind of pipeline, right, to turn A into B. And let's use a shape for that. Yeah, nice fat arrow. Okay, so to do that, you can think of this whole box as the generator, right? But what I actually did, because back then I didn't know much, is I cribbed this kind of image generator off the internet, and it's called You Got It. And the reason why I picked this is because it was new at the time. It's really out of date by now, but you know, a couple years ago it was kind of the new hotness around. And now you might be wondering, what the heck does an image generator have to do with audio? Well, the thing is, audio can form a kind of picture if you plot it out using what we call a spectrogram. So here's what a spectrogram looks like. Spectrogram is basically a picture where the y-axis is the frequency of the sound and the x-axis is the the x-axis is time, and basically you get the intensity at different frequencies of this spectrogram. So another question here from my partner, where do you source these models? So let's see. You know, the internet's pretty amazing with deep learning research these days. Everything's open source, everything's available online publicly. So what I did was I basically went to GitHub and picked up their official repository there. In fact, I'm pretty sure you can still find it. Official, you get it. Yep. So there's a TensorFlow version and a PyTorch version. I use PyTorch, so this is where I got the original stuff. The code, yeah. So yes, I basically lifted that. So here's my ugly spectrogram picture. And the idea here is that once you have it in this form, it's in 2 dimensions now. And what that means is that your spectrogram is going to basically be an image. And so this image generator can just take that image and turn it into something that looks like another image, right? And so you do this over here, right? And of course, the only problem is you have to turn those spectrograms into and out of the audio, right? That's kind of the part that's missing here. And this is kind of where the whole model gets complicated, because now on the left side, going from audio to spectrogram, that's easy. But when you're going on the right side, so let's just make a new picture here. Let's see, just cleaning it up. Okay, so what did I say? The left side is easy, right? So, but the right side is hard. And the reason why is when you go here from the audio to the spectrogram, you're throwing away information. You're throwing away the phase of this waveform. So when you go from spectrogram back to audio, the problem is that you need to kind of infer that the wave phase back into your audio. Otherwise, it sounds like garbage. And so there's like kind of algorithmic ways to do it, as in like math ways to do it. But what I found was there's another deep learning model which is able to do this kind of reconstruction, and it does it a lot better. Like the quality is better. So what I ended up doing was I have this kind of new model here. So first of all, let's label things. Right. And then now here, what I did here was I used, it should be the model that turns it back into audio, right? I used a model called WaveGlow. And what it does is it converts spectrogram to waveforms, so to audio. And so on this side, I just use WaveGlow's like utilities to take the audio into some kind of spectrogram, but that's not important, right? The important part is the part that takes it back to a waveform. Okay, so today, in order to make all of this work, I need to get 2 models working. One is this WaveGlow model, and then the other one is the You Got It model. Now, I'm not too worried about this one because it's kind of pretty bog standard code, but this one I'm a little worried about because it uses something called a Docker container. And Docker container is basically like you take your computer, like a Linux computer, and you package it up into a giant file, and basically that allows anyone else to run the same computer somewhere else. So you never have this issue where it works on my machine, but it doesn't work on your machine because you have a slightly different thing installed, right? Now the problem with that is I'm currently on a Windows computer, so I did all of this on a Linux rig, and then basically because I'm streaming and I might want to stream video games, it's a lot easier to do that in Windows, and that means that in order to interface with Linux, I'm using something called Windows Subsystem for Linux. So you can see it right here. What it does, I jump into it. Oops. This is an Ubuntu thing running. Okay, so my partner says I gotta go for the evening. Thank you for sticking around and helping me troubleshoot, and have a good one. So yeah, back to this. Basically, I've got this. So I've got this Linux system that's actually running through Windows, and it kind of feels mostly like Linux, and except it's not, because it's actually running on Windows. And so I've never gotten this. I've never tried running my models on Linux through the Windows subsystem for Linux. So we'll see if that works here. So first thing is I need to make sure I can see my GPU, which I can. That's great. Second thing I'd like to do is I'd like to have a bigger window. Why is my text so small here? Let's change that. So to do that, I'm going to go to font. Let's go and bump up the font a bit. And otherwise, it's really hard to see on screen on the stream after you compress it down, right? Because the stream's not nearly as high quality. Okay, there we go. Yeah, that looks a lot bigger, right? Good, nice. You know, I had made this terminal look a lot prettier, and it doesn't seem to have saved any of that, so I guess I'm going to do that again. And this seems kind of silly, but you know, if you're going to be working with a computer for a while, it kind of pays to make it look pretty. So since I'm here, let's do it. Let's make it look a little prettier. Okay, so I'm gonna open up those preferences. Just where are they? Properties. Okay, and I've increased the font size a bit. I would also like to change the font, maybe. Let's change it to this. Yeah, okay, that's pretty readable. 28's probably a little too big. So yeah, I also do a little bit of graphics design on the side, so I kind of like messing around with how things look. Right, so now we've got the font, the layout, yada yada. So let's change the colors. So I actually have some stream colors here, and again, it's because I do some graphics design. I picked out these two colors which are nice and complementary, so we're going to just pick out those colors. Oops, there we go. Okay, so in case you're wondering what I'm doing, I'm just opening up some of the materials I used to prep for this stream. So here we go. We're going to copy this color. So it's an RGB. Okay, so we're going to half the window so I can see things. Now we're going to copy over this color. This is the background color. So red 45, green 49, blue 51. Okay, and then for the text, red 250, green 241, blue 234. So that's what that looks like, and I'm going to increase the transparency of the background just a hair so I can see my background, my desktop background, just because it's pretty. Hey, look at that. That's much prettier. You know, makes it more fun to code in, right? Okay. So if you're wondering why I picked those two colors, so the background color is a little bluish, and that's because I kind of like it. It's soothing, right? And then for the color that's the text, it's a slightly off-white, and the reason for that is when you have colors, you kind of want complementary colors, right? So colors that are kind of on opposite sides of the color wheel, and orange is kind of opposite to blue. So in this case, I've increased the contrast of the text versus the background a hair by making the text a little bit off-white and a little more on the orangey brown tannish side, right? And that way you get this kind of punch between the text and the background, which is kind of pleasing from a color standpoint, while being kind of not quite so as like strong as having just pure black and pure white together, right? So they're not quite that differentiated in the lightness values, but they're a little more differentiated in color. Ooh, okay, so that was a long aside. Let's jump back into our models. So let's see, I've got, okay, so let's write a to-do list. Step 1, we need to download Docker containers for Waveglow. Step 2, we need to run Waveglow. Step 3, we need to install stuff for requirements, where you get it. So if you, just as a reminder, Waveglow is the thing that takes audio, spectrograms, back to audio, and then this thing is the image model that actually does the style transfer that makes one voice sound like another, and then run you got it. That's the basic idea. If I'm missing anything, I'll come back and update this. So let's give it a shot. All right, first things first, we need the code. So I've got the code on a different hard drive right now, I think. Let's see. Mount D. Is that where I have it? Yes, okay. Mount DML is where everything is. So we're gonna jump into Cohen project here. So ls is just searching the directory, right? So this is actually a Windows drive. It's just been mounted into the Linux subsystem here. And I've got the code here. So let's see. Council again. Okay, that's a different model I was trying. Deep learning examples. This contains the Waveglow code, so we're gonna need that. These are a whole bunch of ablation things I did as part of the project, so that's not important. This is the training data, very important for actually doing the project, but not relevant currently because the model's already trained. Docker images. I think I was trying to export the Docker image from my Linux thing. It just didn't work, so I'm gonna download a new one. This is the final checkpoints that I trained. Similar here. Other checkpoints, not important. Waveglow checkpoints, not important. So we just need the code here, which is this thing. Oh, and I guess also my code. Do I have that? Uh-oh. Do I have that? Okay, I'm going to check. That doesn't seem like it. Yeah, so I might be missing some code here. I'm gonna need to, yeah, let me think. I'm going to need to download something to open my Linux drive. ext4 for Windows. You know what? I'm going to mess with that in a moment. Let's try to get this Waveglow working first. So I'm going to copy over everything in deep learning examples, which contains the Waveglow code. So let's do that. It's called deep learning examples. So we're gonna copy everything in here. So to do that, we need copy minus R for recursive, and we are going to take it, let's just take it to my home, right? Because I have nothing here right now except env. So let's make a new directory, and we're just going to copy over yeah, okay, let's try that. Oh, it doesn't want to open it. Okay. Well, there's always this. Okay, so what I just did was, I think there's a permission issue, so I'm just going to use sudo to copy things with administrator privileges. Okay. Now, that's going to take a few minutes to complete because it's on a slower hard drive. Yeah. So, while we're waiting for that, let's see. Let's go back to the plan. So I need to download Docker containers, and if I recall correctly, well, first I need to install Docker, of course. So, yeah, this is quite slow. We're going to open up a new. Yeah, it's copying right now. Okay, so we're going to need to install Docker. Actually, you know what? Let's follow the README for this. That would make a lot more sense, right? So it should be under PyTorch. Let's see. Speech synthesis. And then there's a thing called Tacotron 2, and Tacotron 2 is a general speech synthesizing thing, and inside Tacotron 2 is the thing that we actually want, which is WaveGlow. And I don't think it's loaded yet. Okay, it doesn't want to open. That's okay. That is okay. So let's see. I can always open it in the previous drive where it was. Tacotron 2 WaveGlow. Okay. That's strange. I mean, if in doubt, right? Just put sudo before it. Okay. Yeah, so interesting. Ah, it must be here. Yes, there's the README. Okay, I want that README. So let's take a look at what's inside. Okay. So this is just some instructions, so we're gonna skip over this stuff. We just need to go straight to setup, right? Model overview, architecture, default configuration, mixed precision training, yeah. Setup. Okay, here's the important stuff. So yeah, we need the NVIDIA Docker, this Docker, and then yeah, I have a supported GPU because this GPU did work. So, getting started. You know, it's been years since I did this, so it's kind of easy to forget what I did. Okay, so let's see. Version quick start. Okay, so clone the repo, which I did. Go into Tacotron. You have a bunch of scripts. Yeah, okay, so I just need the Docker container. So the Docker is, let's see. We're just gonna take a look at what this is. Okay. Right, these are GPU Docker containers. Okay, I remember this being a pain. I just don't remember how much of a pain it was. So, I have the NVIDIA driver because I do see it. So it looks like I just need Docker first, right? Okay, so let's try that. Apt list. So I'm just gonna look for Docker. Looks like there is various Docker things I can install on Linux. So yeah, so I just need the Docker engine. So let's look up how to install Docker engine. I don't want the docs. I want to install. Okay, there we go. Docker for Linux. Okay. I mean, I could just try one of these, like Docker Focal here. Yeah, let's just try it. If you're wondering why I'm so cavalier with my Linux installs, it's because I'm not trained in computer science formally, so everything I've picked up kind of on the go, right? Okay. Now I do remember you do have to start a certain service on Docker to get it working. So it's actually this thing that runs in the background. So we're gonna look up how to set up Docker on Linux. Yeah, this is really kind of the authentic programming experience where you spend 90% of the time reading manuals to try to get everything working. So, let's see. Prerequisites, we're just going to assume that we've met them. Yeah, because I've got 20.04, yep, so I meet the system requirements. That's fine. So I use the repository. Yep, so that's what I did. That's fine. Install. Oh yeah, I forgot to run this. You're supposed to run that every time. I always forget. I mean, it's a little too late for that now, but we'll run it anyway. So this just makes sure I have the most recent software. Yeah, I think it's fine though. I mean, just in case. Let's see. Yeah, okay, so that's not part of Docker, probably. Okay, so we've installed that. We've installed this, I think. Ooh, there's some dependencies we're supposed to install. These things, so sure, let's install those. Looks like it's already there. Perfect. Okay, now. Install Docker engine. Wow, that's a lot of things, huh? Okay, well, you know, we'll just do it. Oops. Alright, I'm always using the Linux commands here. Control-Shift-V to paste. But obviously, that's different here. Oops. Okay, what does that do? It sets up repository, okay. So it should work now. I just ran updates, so we just need to install all of this extra stuff. Cannot find it. Oops, sorry. Okay, Right, it needs to update again because I just added some new repository for it to pull software from. So yes, now it sees everything. Okay, time to eat up all my my disk space, as these things tend to do. I mean, the actual Docker container for that I have to run for this model is like something like 10 gigabytes. It's kind of ridiculous. Right? It's because it has to like fill, like, it has to store all of this stuff about like your system configuration. I'm not gonna pretend I know anything about Docker. I just follow the instructions, right? So yeah, okay. So this will take some time. At some point I'm going to be downloading that like 10 gigabyte Docker file, like the Docker container, and it's going to take a while, and maybe that'll be a good time to run over the presentation that I made for this project. So yeah, we'll get there when we get there. It's just taking its sweet time. Let's see what else is going on here. So I guess 1A here was install Docker. 1B is going to be NVIDIA Docker. So the idea is that Docker is kind of like its own little Linux system, but then in order to expose your GPU on your real computer to this kind of virtual computer that Docker's running, you need this particular NVIDIA thing, right? So this thing. And the problem is I don't remember this. So I guess when I was installing Docker back then, I completely missed that I actually also installed NVIDIA Docker. And I'm like, was that a headache? Was that a pain? Because in my experience, trying to install anything that's NVIDIA is kind of like rolling the dice, especially on well, actually just in general, right? Because there's just so many things that can go wrong. And yeah, this is one of those things where I'm thinking maybe I should have done it offline. But on the other hand, like, this is a test stream, so whatever. Right? If it takes longer, if everything fails, no biggie. It's not real anyway. Okay. So let's see. NVIDIA driver. I'm just going to read over this. It's kind of like reassurance, right? I'm doing the right things, hopefully. So NVIDIA driver, do I have this? I really should, because I can see it on my Linux distribution. The Docker engine, that's what I'm getting now. Okay, do you need the CUDA toolkit? You don't. Excellent. So I don't care about that. There's an NVIDIA container toolkit. What the heck is that? Oh, this is the NVIDIA container toolkit. Okay, excellent. So I just need this, right? Okay, so here's some other instructions, because NVIDIA is like that. You've just got documents everywhere. So let's see. It says to install for Docker. Okay. I'm installing Docker, that's fine. Installing on Ubuntu and Debian. Following steps can be used to set up NVIDIA. Okay, that's fine. Oh. Well, why'd I follow all those instructions if I could just use their convenient script to install it? Okay, so this is what I'm supposed to be doing right now. Let's see how that's coming along. Processing triggers. For some reason it's frozen here. Okay, I'll give it a few more minutes to see if it unlocks, but otherwise I might have to kill it. Okay, so the idea is once you install Docker, then you set up this. This is what I'm going to run next, right? After I install Docker. So it looks like I have to get a new repository, somewhere to download software from. And I don't care about that. And then looks like I just need to run this. Yep. Okay. Great. Ah, I see why this is stuck. It says could not determine current run level. See, these are the kinds of mysterious error messages that get you when you're trying to install things. Okay, well, let's, when in doubt, Google. Installing Docker engine. Okay, we're just gonna scour this to make sure I did things right. Okay, I don't want a specific version, right? I just want the engine. So I ran this guy. And this is where it could not determine current run level, so we're just gonna search up this. Oh. Hey, well, it finished. Okay, I don't know if it worked or not, so I guess we're going to find out now. So in order to do that, yeah, we need to start this service, so Docker runs in the background, right? And it might crash terribly, or it might work. It might have worked. Okay, well, let's try this. It's kind of frozen, isn't it? You know, for a moment I had hope. Let's see what services are running first off. And I don't know the command for that, so I'm going to Google it. Linux services. How to list all used systemctl, right? System control. Okay, followed by list units. List units. Okay, that didn't work. Oh, here's a different one. Service. Okay. Interesting. There's Docker. Now, what does the plus sign mean? Okay. Well, let's just try running the next command. Sometimes, you know, you can just keep running things until something breaks, right? So, let's see how that works. Okay. Hey, it worked. What do you know? What a great feeling that is when everything that you installed actually works magically. So, so this basically is some kind of Docker image. So it's one of those prepackaged Linux systems. And so let's see. You couldn't find it locally, which makes sense because I just installed Docker. Nothing else is here. So because I couldn't find it, then it downloads it. Yep, there's the hash. So it downloaded this image of this hello world kind of test Docker container. And then if it generated this, then it did everything right. Okay. Now I have no idea how to stop this, but I think you can just stop it, right? Okay. Actually, I think it might have automatically stopped. Okay, so next. Next step. NVIDIA Docker. It's just like a shell game, you know? Programs within programs. Okay, so we got Docker. That was up here, right? Yep, so now we need to set up the NVIDIA container toolkit. So we're gonna run this. So, do I want the experimental branch? No, so we're gonna skip that, right? Yeah, okay, cool. And then, oh my gosh, why are there so many things? For versions of the NVIDIA Container Toolkit before 1.6, use the NVIDIA Docker repository. Okay, the problem is I don't know which version I used. Like, this was 2 years ago. Yeah, because I remember, I think I used NVIDIA Docker here. But because I'm creating a fresh one, it should be fine, right? Yeah, so let's just keep following the instructions. Keep following them until something goes wrong. Okay, so you need to refresh. So basically we're just, updating what software is available, and then we install this guy. Let's hope it works. Well, it looks like it worked. Okay, we need to restart Docker. Right. I don't think systemctl is being used to manage services here. So let's see if there's another way to restart Docker. Because Docker itself might have, yeah, it definitely has a command, right? But the only problem with this is, I think this is restarting the container. We want to restart the Docker service. Right, so Docker is this program. You can restart things within the program, but we want to restart the program itself. Okay. Yeah, I'm a little mystified that it's not system control that's managing the services here. Okay. Yeah, system control is not going to work here. Okay, well, Stack Overflow might help. Let's see. Let's see if this works first. Yeah, Docker's running. Good. So it might be service, right? Yep. Yeah, let's use the service command. So, might be something to do with Windows subsystem for Linux. I don't know. As I said, I'm not a computer sciencey guy, so I'm pretty clueless as far as these kinds of things go. So, looks like I just need to run sudo service, and then the name of the service, which is Docker, and then stop. Yes, that worked. Okay, now we just need to start it again. Okay, great. So we restarted Docker. That's that. Now we just need to run a base CUDA container. So CUDA is NVIDIA's like computing, you could say API, yeah, application programming interface. So it's just all the stuff that makes. Oh, hi Dennis. Hello. Sorry. In case people don't know. So this is my brother. He's one of the people that helped me with this project. Let's see. Big shout out to Dennis for, producing the song that I ended up doing. And also, just staying up really late at one point in 2020 in order to get this project done. So just to catch you up right now, what I'm doing is I am trying to get the Leonard Cohen robot voice that I made working again on my new computer. Well, technically it's not a new computer. I'm just stealing my wife's computer. Right? So the main issue is that when I did this project, it was on Linux, and now I'm on Windows, and I'm using Windows subsystem for Linux. So yeah, basically we are in installation hell trying to get all the things that were working again. And it's one of those things where it's like, you know, back when you install something for the first time, it creates such a negative experience that your brain just blocks it out, and you kind of forget entirely about how it was done until you try to do it again. And that's what we're doing now. Just another point is, I was just gonna mention that the music right now is kind of a work in progress. So please, if you have any comments about the quality of this jazz that's happening in the background, don't hesitate to let me know. My brother is a amazing jazz musician. He knows all about jazz and various kinds of music that I don't know about because I mostly taught classical music. So yeah, it's kind of a work in progress. I was considering lo-fi as another alternative. I'm trying to keep a chill stream here, so nothing too up-tempo or loud, but hopefully this kind of gives a nice elevator vibe for the stream, elevator stream. Okay, back to work. Let's see, we have Docker, right? This thing, I think it's running Docker in this program or something. Oh no, it's fine. Okay, it's just this console's a little screwy. So it said starting Docker, but it didn't give me a prompt because it like went backwards a couple lines for some reason. Gosh, it's always so confusing working with different systems. I'm not hip enough for lo-fi, I'm sorry. Well, I mean, this is exactly what siblings do, right? They tell you you're terrible and you should feel bad for being terrible. That's okay, I will stick with elevator jazz. Okay, so we got Docker. We're trying to get NVIDIA Docker, and the reason why is this is all very convoluted way of running NVIDIA's WaveGlow program, which is what I use to take the... so if we go back to our agenda, so here's where we are, right? We have a spectrogram, we need to turn it back into audio, and in order to do that, we need this WaveGlow model here. And then after that, I'll get the image generator, which does the style transfer. I'll get that working afterwards. So one thing at a time, we'll start with this WaveGlow model. Okay, and in order to get that WaveGlow model working, we need this thing called Docker, which is the basically virtual computers that you can download. And that standardizes, you know, what's installed, what's not installed. I mean, like, I get that these are really important for, like, you know, companies doing stuff like setting up servers, but you know, for this kind of like research stuff where you're just trying to get something running locally, like, I think Docker's really overkill, and I'm a little annoyed that, you know, NVIDIA stuck everything into a Docker container because now I have to install all of this crap, right? So we got Docker, that's good. Now we're working on NVIDIA Docker, which basically lets the graphics card talk to Docker, because right now if I opened up a Docker container, it would basically say I don't have a graphics card, which is bad because these models really need a graphics card to run in reasonable amount of time. Okay, so let's get back to it. So as you can see, I've got the docs open because, you know, that's the only way you can get anything done is by Googling everything. So I just restarted Docker after installing NVIDIA Docker. So now we're going to try to run this. Hello? Huh. This window does not want to paste. That's funny. Okay, let's try this again. Ah, there we go. Okay. Okay, that's good, right? So sudo docker run, run some stuff. Ah, I see. So basically, it's asking Docker to run, but with this GPU as well. And now you can see NVIDIA SMI, which is basically the it's like the control panel for NVIDIA, right? And what do we see? We have the GPU. We have CUDA version 11.7. Here's the graphics card. It is it's using a little bit of memory. This is because Windows is actually using the GPU to display everything, right? Including the stream. But you can see there are no processes because Linux obviously is not running anything on this GPU right now. That's great. Okay, that's everything I wanted. Okay. So let's take a look through the rest of this. Setting up NVIDIA Container Toolkit. And I always ask, you know, do I actually need this? Do I need this NVIDIA Container Toolkit to do anything? Well, let's see. I think so. Yeah, I do, right? Like, but isn't that what I just installed? Like, what did I just install if it not for this thing, right? Let's see. Because let's see. I installed NVIDIA Docker. I installed NVIDIA Docker, so I still need this container toolkit. Because if I go back to WaveGlow, where's that wave? You know what? I'm just gonna look up on GitHub where I steal all my code. Let's see. I'm just gonna search GitHub. If I can spell, GitHub NVIDIA Deep Learning Examples. So that's where I got this. Yeah, this is the one. Okay, but I also need to find the specific model I'm using, which is very confusingly called, let's see, it's under speech synthesis. It's called Tacotron 2. And I'm only using the WaveGlow part of Tacotron 2. And if you're really confused as to why this is, it's because I was looking for pre-trained checkpoints, and the only ones that I could find working at the time were under this particular repository. Wow, that was loud. Okay, so the funny thing is, NVIDIA is a complete mess, right? They have stuff all over the place, and I remember looking through like half a dozen different checkpoints for WaveGlow, and they were all slightly different, and they all use slightly different code repositories. And eventually I found this one that worked, and I stuck with it. So that's why we have a model that's called Tacotron, although we don't need that. We only need the WaveGlow part. So let's see. Performance, okay, yeah, we don't care about that. We just need the README. This is the README, so we're jumping to setup. Okay, so requirements. NVIDIA Docker, we got that. Nice. We need this NGC container. So I'm guessing this is the Docker container we actually need to download. Oh no. Now we have to dig through the mess that's called NVIDIA's this is exactly what I was talking about. This catalog is their, dump of all the files they have that you might use, except it's not done in any logical order. So we're just going to look for it, right? So we just need PyTorch 20.06 Py3. So we're just gonna search and hopefully it shows up. Okay, PyTorch container. View labels. Okay, I mean, that seems reasonable, but how do we know it's actually 20.06 and so forth? Let's just scan around first. Merlin PyTorch, don't care. PyTorch Lightning, don't care. See, like, why are there so many? Who knows? ResNet, yeah, I definitely don't need that. That's going a little too far. Okay, so we are just going to use this, I think. Copy image path. Okay, what does the image path look like? Let's find out. Okay, that's the image path. Okay, how do we get into Docker? That's the question now. There's some more information. Excellent. Okay. Yet more documentation. This is kind of the life of programming. You spend 10% of your time writing code and 90% of the time trying to find stuff or, debug things. Okay, so we've got your documentation here for catalog. Okay, do I really need this? Okay, this seems more relevant. Okay, pulling a container. So, first of all, installing. I think I did this, but I'm just gonna go through it again just in case, Let's see. Yeah, I got NVIDIA Docker. That's good. Let's see. Yeah. Yada. Docker best practices. The NVIDIA drivers are installed in the container, and then they're mapped. I mean, I think that works because I just ran this. Yeah, I ran this earlier, right? So you know what? Let's run this and just make sure it works, right? Oh, I need sudo. So this requires your administrator privileges to run. Error response. Cannot find stuff. Yeah, you know, I'm not even surprised. Like, NVIDIA stuff always goes out of date, so I can't find this on their servers. I'm just gonna skip that. Okay. Okay, so this is their Docker repo. Yes. Okay, so the thing I was just looking at, which is this PyTorch container, that is on that, right? Oops. Yeah, this is the one, right? nvcr.io. So this is where we want to be. I'm just gonna echo it here so I don't forget it, right? So this is the thing we want. We just need to figure out how to bring it into Docker here. Okay, so building containers. Yeah, so we've got that part. We need to build this container now. Let's see. Okay, actually I don't need to build a container. That actually means making your own container, so I don't need that. Skip ahead to pulling a container. Yeah, I've got Docker installed. Preparing to use NVIDIA containers. Okay, you know, and I'm gonna ignore whatever GGX is, because I don't need the fanciest features, I just need it to run. Okay, yeah. Okay, so I think you run docker pull. That's what it says, yeah. And then run. Run is to actually start the container. And usually if you run docker run, it will pull it automatically. But you know, just in case, I'm going to pull this first. And this is probably gonna take a while, because I imagine this is the 10 gigabyte thing. Docker pull, and we're gonna take this, right? Oops, I need a copy. How do you copy in here? Yeah, I'm just gonna go back here. Copy image path. There we go. Okay, we'll see how that goes. Bye storage. Alright, sudo. Okay. Yeah, that's a lot of data. Look at that. 2 gigabytes. Yeah, it'll take a few minutes, as is tradition. So I personally think it's ridiculous. Like, why do you need so much? Why do you need so much? Okay, but that's how this works. If I want to use this model, I gotta go through the hoops. Right? Let's see. Let's go back to here. So I'm getting this container now. Okay. And then I think once I have that container running, I can just try running the model, which is great. Okay, so while that's downloading, let me just quickly run through the files I have for this model and make sure I've got everything kind of ready to go. So we are going to open up a new window here. I'm just gonna jump into, let's see, change directory to, right, I already copied the files, right? So it's under Cohen project, deep learning examples. Yes. PyTorch, speech synthesis, Tacotron 2. Okay, so that's where we're going. And I think I've already got some scripts in here that I made specifically for this project. Yeah, it's under voclone, because that's what I was calling the project at the time. And let's see. Yeah, I've got checkpoints. Yeah, and right now, apparently I don't have permission to view these. Right, so I'm just gonna take ownership of everything in here. Let me look up how to do that, because I don't quite remember. Chown is the thing that gets you ownership of files. I just don't remember how to do it recursively. With capital R, capital minus R. Oops, I'm just gonna leave those open for now. Okay, so let's try that. before we do that, actually, let's make a symbolic link to this folder. So what I like to do sometimes is just make a link that's easier to get to than cycling through all these directories. So we're gonna change directories to here, and we're just going to create a symbolic link. And I always forget how this syntax goes, so let's, oops, not ls, man ln. So this is the manual for ln, which makes links. Let's see, it's option, then target, then link name. So we need the target first. So at -s is symbolic, so that means it's a shortcut basically, and we're just going to shortcut into that Tacotron folder or a directory. So the target comes first, so we need the target, which is Tacotron 2. That's our target. Okay, now our short name or shortcut name, we're just gonna call this Tacotron 2. Or we could call it wave glow, because we're really only using the wave glow part, right? Okay, now we have a shortcut, right? So if I go look in the directory wave glow, yeah, I've got all the same files. That's nice. Okay, and looks like the looks like the Docker container also finished. Excellent. Okay, so we're going to close that up. Okay, so there's a whole bunch of stuff here, and it's in a complete mess because, I mean, I was in a hurry back when I was doing this. So I believe there is a script to run. Oh, first I need to own all these files. Can I do that? Missing operand. Okay, maybe I have to. Oh, okay. Let's make sure I'm using this correctly. So I just want to own these files, so I don't need to keep invoking the administrator privileges. So it's option, then owner, group, and then file. Okay. Change the owner of each. You know what? Sometimes it's easier just to look up an example online. Okay. CH own, some user, some group. Ah, okay. Wait, that's the wrong way. Yep, no, that's fine. So long as I run it on a directory, right? CH own, some user, some group. Okay. We're gonna do exactly that. I think I have this. I don't actually know what user I am. Yeah, this is kind of my lack of computer science showing here. Right. Who am I? Devin. Okay, that's great. Okay, let's try it. All right, I need to run this as an administrator, obviously. Okay, that should work now. So if I take a look into this again, and it's still permission denied. Why is that? Who owns this? Yeah, right. I don't have that alias set. Okay. Yeah, it's owned by root right now. That's kind of the issue, right? I mean, I don't really want to mess with this longer, so let's just keep running sudo every time I want this. Okay, that's fine. Let's see. Docker, prepare dataset, prepare mels. Okay, so these are a bunch of scripts. We don't need the training ones, right? We don't really, I mean, we might need some of the other ones, but really what we need is the Docker script. So we need to start this Docker thing. Yes. So I think this is what we need. We're just gonna take a look at it. NVIDIA Docker run. Okay. Whole bunch of stuff. Password, workspace. Some of these things. Okay, so a lot of these are just not that important. The important command here is NVIDIA Docker. So we're gonna make sure we can run this first. Yes. So this command exists. So now we just need to see if this shell script runs, right? Command not found. I mean, what? Oh, it's probably not it's probably right, yeah. The thing with Linux is it's got slightly different permission structures to Windows. You have to tell Linux that something is an executable file that you do want to run. And so let's change that. So chmod plus X for add execution, and then interactive. And of course we need to run sudo, right? Okay. Let's just take a look inside here again. This really is biting me in the butt. Oh, you know what? Before we move on, this ownership thing is really annoying. So let's just let's try something. It's still not working. Okay, that's fine. Yeah, I own everything in here. Yeah, I even own everything in here. So why won't it let me open it? That's really strange. That's really weird. Oh, okay, let's take a look at these. So yeah, I think the problem is I mean, I took ownership of the files, but I still don't have permissions. So this shorthand over here with the dashes and X's, that's just a shorthand for what you're allowed to do with this particular directory or file. And right now it's only got the X's. So X is short for execute. We need read and write, RW, right? So let's just do that. Chmod plus RW to everything in. Right. Hang on. I also need to make it recursive, right? Recursive capital R. Okay. So recursively modify the permissions of everything in WaveGlow to read and write. Okay, let's see if that worked. Read and write. Okay, that looks promising. Yes. Okay. Man, sometimes the little things trip you up. Okay, so what we were doing here is we were looking into the Docker script, which is interactive, right? And we need to make sure we can run it. So let's try running it. Right now, permission denied. That means we need to give it the privilege of running using chmod, change mod. Okay, let's try that. And then try running it again. Permission denied, right. We need to run this as administrator because anything involving Docker requires this. Okay, it can't find this image though. Okay, so at least it's running, but it cannot find this particular image called Tacotron2 latest. Well, that's very annoying. Okay, I guess we are going dumpster diving in NVIDIA's stuff again to try to find this particular. What is this? Tacotron2 latest. and GC. Okay, this is good. So, first of all, we're on their catalog of stuff for NVIDIA files. Let's see. Okay, yeah. We're gonna skip all of the information and just see what this actually is. Well, it's a resource of some kind, but I can't tell what kind. It's a model. Yeah, let me guess. Let me guess. What do you know? This is only the code, which I already have, so that's useless. I need the Docker container. So let's just take a look at this again. NVIDIA Docker run. Okay. What is it trying to run? Password. Workspace Tacotron 2. Okay, don't care. So this part, the V part, means these are just directories that are being exposed to the Docker container here. Right, so that doesn't matter. What matters is probably, let's see, the last part says bash. So that's just starting the shell within your Docker container. That's fine. Tacotron 2 then must be the name of the container. So I'm really confused because why is this container called Tacotron 2, but I can't find such a container? Let's dig around a little. There's a Docker file. Okay, what's that? Aha. Okay, so it says... okay. So this Docker file probably tells you what it is, right? Yes. So you can see, it tells you, so this is the Docker file. This is the container that we want, right? Yeah, because this is the one I downloaded earlier. That's great. And then it just gives it a name of Tacotron 2. Yeah, and then it runs a pip install. Right, so this just installs the requirements onto, so the idea is that it creates a new virtual Linux, right, using the Docker container, and then it runs this installation thing to get all the requirements into that environment. Okay, so we just need to know what to do with the Docker file now. So, Googling again, Docker file reference, okay. Docker file can build images automatically. That's what we want. Okay, so how do we run it? Docker build. Okay. Docker build. But do we need to tell it which thing to build? Yes, you can do Docker build -f. Okay, so that's what we want. Docker build -f, and we need the path to the Docker file. So that should be just waveflow Docker file. And why do we need the dot? That kind of implies, so the dot means the current directory, right? So is it building something to the current location? Yeah. Okay. Builds to a location. So maybe we should go into this directory where the Docker file is, and then just run Docker build, and it should pick up the Docker file correctly on its own. It still needs a path. Okay, that's fine. Right, so it probably builds to this path, right? Right, and we need sudo again. I always forget. Docker, you always have to run stuff as the administrator, and looks like it's working. Sending build context to Docker daemon. Look at all the gigabytes you need to run one measly thing. Okay. Progress. Progress is happening. You know, I thought this would be a short stream. We'll see how long this stream ends up being. It's been what, 1.5 hours of installing and downloading. This is really great. That's sarcasm, by the way. Okay, so while we're doing that, let's clean up the desktop a bit. I don't need all of this random stuff, do we? I think I don't need this stuff anymore. I mean, part of me is worried that I'll be running things and then I'll say, oh, hey, by the way, you need an NVIDIA container toolkit. That would be very annoying, but let's hope that doesn't happen. So let's close up the tabs. It's always very satisfying to close all the tabs after you finish doing something, you know? Oh my gosh, look at that. Apparently it didn't fit. Wow, look, it's downloading more stuff. So apparently that image I downloaded, that Docker container, it's not everything. There's still more stuff to be had. Unbelievable, you know. I sure hope this computer still has drive space after I'm done. Otherwise, my wife's gonna be very mad at me for, you know, taking up all her drive space with Docker containers. Okay, so let's see, deep learning. Okay, yeah, we did that. We did the containers. We did that. We did that. Okay. So, in theory, everything's ready. And once this container updates, what we're going to do is start the Docker container and then run the model, and hopefully everything goes as planned. You know, that's the whole point of Docker, right? Once you have the right container, right, the right image, then everything should work because, you know, the whole point was to remove these dependencies that could change, right? To make it like frozen and make sure that the environment you're running something in is the same every time. So, okay, let's just assume that's going to work. So we did that. Done, I think. Well, we'll put a question mark there, right? Install Docker, done. NVIDIA Docker, done. Okay, and C is images. Download images for Tacotron. That's where we are right now. These are not very attractive colors. Okay, so. Okay, so we're going to assume this works. Let's get a head start on this. So the actual code I ended up running was pretty heavily modified from the repository. So I can't just go to their repository for this style transfer model and just copy their code again. I need my code, and unfortunately I left it on my Linux drive. And now if you know anything about Linux and Windows, is they use different file systems. And so Windows literally cannot read the Linux drive, but luckily you can download programs that can do that for you. So I'm gonna find one. How to read ext4 partitions on Windows. ext2 read, or Linux reader. Now, I do know this. I've used this before, so I'm just gonna find this. Oh, incidentally, why is this Google? You know, I get very easily distracted, but let's just change the default search engine, because I'm quite used to using DuckDuckGo. And I'm also going to add a separate search bar. Yeah, that's much nicer. So if you haven't used DuckDuckGo, it's just a different browser search engine. And the thing I like about it is that you can just instantly go to different search engines using this kind of bang command. So if I want to search Google, I just put put this exclamation G in front of it. Or the things I tend to search for a lot is Google Scholar, GSC, right? And you know, stuff like YouTube, Wikipedia, so you can do W for Wikipedia. And right? Okay, anyway, that's a little off track. Let's get back to this. So, ext to fsd. You know, I would download off SourceForge, but I'm a little suspicious of SourceForge. So let's see what else they have. It's also a SourceForge project. Linux reader. Sure, let's try it. I mean, it's probably not a virus, right? Yeah. Okay. Okay. So, while that's happening, let's go back to seeing what's going. Oh, I probably shouldn't have hit all those yes buttons. Okay, that's fine. We are going to ignore that for now. Take a look back here. Requirements. Looks like we finished building the Docker thing, the container, so that means we should be able to run it now. So we're going to try running that script again. Script interactive. Waveglow interactive, right? What is it called? Docker. Okay, ls scripts docker interactive. Okay, so we're going to try running this. Sudo. You can still not find this. Interesting. That's a little strange. Did I not set up this thing? Did I not set up this thing? Okay, we are going to check to see what images are in Docker currently. List. That is not right. So these are to list images that Docker could download, but I want the ones that I have, you know. Docker list images. Local. Okay, so it should just be Docker image list. And I need to run sudo again. Okay, so let's see what we've got. We got hello world, we got PyTorch, and CUDA. Okay, that's fine. So what happened to the one we just built? So it gives you, so a lot of these programs give you little hash numbers that tell you exactly what it did, right? So it built 8853 yada yada yada. So that should be this container right here, right? Yeah. But for some reason it's saying repository none and tag none. And that's a little weird, right? So it really should have named it, because according to that Docker file, right? Let's see. If I open this Docker file again, it says this, right? Okay, so I think we just need to rename this thing. Oops. So, Docker, rename image. Okay, so there's a tag and the actual repository. I guess we are going to name the tag Docker image tag server. Wait, okay. We actually need this. Okay, so we need the actual image ID 88535 3B8EF28, and let's see. I think we can just call it whatever it's looking for in that. So I think it's looking for Tacotron too. I'm gonna check this again. Yeah, so I forgot to run sudo there, but before we do that, I'm just gonna make sure I'm calling it the right thing. Tacotron 2, yes, okay. So Docker image tag, blah, blah, blah. Just run the sudo. Now we're going to list everything again. There, yes. So now it's got tacotron2, latest tag. Okay, hopefully this works. So we are going to run that script again. This script just starts the Docker container, and it works. Yes. Okay, so I mean, it looks like absolutely nothing has happened, but inside this computer, it's basically running another computer, and this computer has everything downloaded that you actually care about to run this particular model. So we're just going to check that first of all. We'll make sure you can still see the GPU, because now it's like the GPU is being sent from Windows to Windows subsystem for Linux, and then it's being sent into the Docker container. So it's like there's kind of like 3 layers going on here. Okay, so that's NVIDIA. That's the GPU. We can see the GPU. Let's see what's installed here. So according to what we had earlier, inside that Docker file, it should have installed a bunch of things for Python. And these are kind of software libraries that are required. So that looks promising. So it's running Python 3.6. You know, actually, let's do it this way. Pip freeze. So this pip is the Python package installer, and we're just gonna take a look at what it's installed here. And that looks very promising. As you can see, it's installed a whole bunch of stuff. I keep trying to use you know what I really should use? I keep trying to use page up and page down to move, but this shell does not work that way. So you know what I should use is tmux. So tmux is like a shell emulator, so it gives you a shell within a shell. You see there's kind of a trend happening here, right? But unfortunately tmux isn't installed in this particular container, so we might just exit the container first, run tmux in the outside computer, and then run the container inside tmux, inside the shell for, you know, Linux, inside Windows. Okay, so yeah, let's just try that again. So we're gonna run interactive again. As administrator. Okay, the reason why I ran tmux is because now I can actually, you see, I can actually split the screen, right? And I can also scroll up and down using the page up and down buttons. So tmux is just a little easier to work with than the shell that I was in before. Okay, let's see. So now this is the Docker container that's running. So it's the computer within a computer. And now we need to make sure we can actually run. First of all, we need to make sure we can see the files we care about, right? Yeah, I think it's just here, right? Yeah, so you can see there are some checkpoints. These are like the trained models, so I had to take this model and fine-tune it on the Leonard Cohen data I had. And the reason why is because originally this model was designed to like basically create like, you know, call center speaking, you know, that kind of speech. And so Leonard Cohen's voice is like really low, right? And so there's a lot of there's a lot of like sounds that this model was just not able to reproduce correctly. So I basically trained it on the Cohen data I had, and so it works a little better for those low ends now. And one of these checkpoints, I think this checkpoint here, that's the one I ended up using. So we're going to try using that, and I believe I have a script to actually do all this running, and it's probably called infer.sh. So I'm just gonna look at that. Python synthwaveglow.py. Okay, that looks promising. So it's calling Python to run this code file, and input is voclone data infer, and output is voclone data out. Okay, so we're gonna make sure there's something in the input folder. data, infer. Okay, infer should be where it's pulling from. So you can see these are actually things I've already pre-converted at some point into the format that I need. Right? These are spectrograms. The mel thing at the end just indicates it's a mel spectrogram. And that's a specific kind of spectrogram that this model uses. It's not really important, the details, but yeah. We are going to try converting these. So let's take a look at out. Out is where it's going to save to. Holy crap, there's a lot of things here. Okay, so we're just going to... let's just delete everything here first, right? Or, you know... Okay, I don't like deleting things, so let's just move it somewhere out of the way. Okay. This is a great way to create lots of clutter, but that way we can compare to make sure it's actually working properly, right? Okay, so I don't think we need that many things to test out, so I'm just going to maybe like copy out like one of them, right? So I'm going to do the same trick. I'm just going to move it to and then I'm going to move one of these. Oh, I need to make a directory first. Okay, and then I'm just going to copy one of those mel spectrograms back so that we can test on that. Data, infer old. We'll just pick the first thing that we see. Okay, we're going to copy that into data infer. Okay. Let's see. Yes. Okay, now we have one file that we're going to convert. So let's find the conversion script. That should be this one. Eh? Wow, that looks terrible. Okay, that's a little better. Okay, right? Yeah, so it says this is the script. Yeah, okay, so we're just gonna try running it now. Good luck. Permission denied, right? So I need to give it execution privileges and then try running it again. Fingers crossed. Let's hope this works. Well, okay, it almost worked. Let's see. This is good news, actually. You might think it's bad news, but it's good news because, as you can see, this traceback, this error message is coming from within Python. And that means that I probably have all of the software that allows me to run Python at this point, which is already a lot further than if, let's say, I didn't have the right container stuff installed. I probably wouldn't get this error message. So this is progress, as strange as it may seem. Let's see. Pickle module. So it's trying to unload, so it's trying to open some data, probably the checkpoint. Let's face it. Yeah, so you can see here, it's running load and setup model, and it's trying to get the state dictionary. So the state dictionary just stores all of the weights that this checkpoint has. And it's trying to load it from somewhere. And it's trying to load that thing, and then the pickle data was truncated, which probably means that the file was not fully copied over. That's generally what that means. So let's take a look at, first of all, which checkpoint it's trying to load. And then we'll take a look at that file and see what's going on. So I'm just switching to a different window here. You know, it might be easier if I tile them vertically, actually. So let's try that. If I remember the command for this. Okay. Google cheat sheet, help me. Tmux tile horizontal. Or split, I should say. Control B. Control B percent sign. Man, who invented these shortcuts for Tmux, I wonder? They're very unintuitive. But there we go. Okay, so we just split the window in half. That way, you know, I can look at the error message on the left, and then on the right, I can do stuff, right? So let's see. Where are my actual okay, so it's running synth waveglow. So let's take a look at that file first. Right? So we're going to open up synth waveglow. Okay, so it's got a lot of stuff, but the important stuff is where it's loading the file, the model from. And it looks like it's we don't care about that. Skip down. Aha, add argument waveglow. So this is where the checkpoint's coming from. The default is voclone /checkpoint waveglow last. So this is the file we're looking for. Checkpoint waveglow last. Let's take a look there. Checkpoints. Okay, so this is what it's trying to load. And the first question is, did that get cut off when I was copying it? So we're going to take a look at the size. No. So I'm just turning the sizes into like a human readable format. So you can see that this checkpoint is way too small, right? It's only 62 bytes or kilobytes here. So we want the 3 gigabyte here. That one's the one we want. So, oh, you know what it is? This probably was just a link to this file. Okay, so that's easy enough. Let's just move some stuff around. Right. We're just gonna rename waveglow last to be this guy. Right, so that's the one we want. So I think we can just remove waveglow last, right? Actually, we don't even need to do that. We can just move it directly on top. It'll overwrite it to 180. And the reason why I'm so cavalier here is because I have all of this stuff backed up on a different hard drive. So if I accidentally delete something, it's not a big deal. But yeah, if I move this, so now, oops. Now this checkpoint has 3 gigabytes of data, so that looks a lot better. Let's try running infer again. Okay, running. It usually takes a while to load up, right? And something oh, look, like, hey, something's happening. Okay, generating chunks. Okay, so it's working. So you can see the file is chunked up because, well, basically the audio is too big to fit onto the GPU all at once. So what it does is it just slices it up and does a little bit at a time. So you can see that happening. That's why I only tried one file, because if you do too many files, it'll take a while, right? Okay, so it almost finished. It generated everything. It tries to write it to a file, and looks like what happens here is it cannot open a file. Okay. So my guess is this directory, because I changed the name of it, right? I didn't want to overwrite that. I forgot to create a directory there, so now I can't find that directory to save a file to. So let's do that. So we are here. We need to go to data. Yeah, so we've got, these are the original ones, right? Infer old, out old, and we want an infer for the input and an out for the input. So we're just gonna create out here. Yeah, so now it should be able to save here. Let's try that again. Time to sit back and let the computer do its thing. While we're doing that, I'm just gonna ask my brother if the sound's still okay. How is the sound? Balance. Okay. Cool. Okay, so it worked. Writing audio to voclone, blah blah blah. Okay, so let's take a look there. It's very clear, nice. Okay, thanks for checking the sound for me. Okay, So here's the moment of truth. We're going to open this file and see if it sounds anything like audio. And if it does, then this has all been a great exercise. Let's take a look. Okay, I need to do this in Windows. Thanks for checking the background music for me. Yeah, okay. So we're going to go... the nice thing is Windows can access all your files. You can see I've got WSL here. That's the subsystem. This text might be a little small for the stream, but yeah. Just trust me that I can see the files in Windows as well, which lets me play them right through Media Player. So let's open it up. Should be under Cohen project. Of course, I cannot. This is the shortcut I created, right? But it only works in Linux, so I have to dig through all of these manually. Speech synthesis Tacotron to WaveGlow. It's not WaveGlow, it's here. You know, I wish there was some kind of way to organize things better. There probably is, but sometimes when you're in a rush to do things. Okay, there's the file. So that's the one I just created after, what, 2 hours of work? One file? Okay, I'm gonna warn you to close your ears. I'm gonna turn off the music for a sec, because we need to hear if this works or not. And hopefully it doesn't blast your ears. Okay, it's audio. It's all cut up because this is like a test sample, right? Sounds like Cohen though. Nice. Okay. 50% done. Okay. And just for comparison, I'm going to compare this with the thing I had generated before, because I've generated all of these files at some point, right? And we're just going to find the same name. Right? What was this thing called? Ablation BG disk, blah, blah, blah. Right? So we're just going to find this name here. Ablation BG disk. This one, right? That's the one. Okay, should sound the same. Yeah, I think that's the same. Okay, I'll just double check one more time. So this is the one I just generated. Yeah, that's the same file. Excellent. Okay, so we're in business. We can create audio, and technically, you could even draw a picture and stuff it into this file, this full directory here, and it will turn it into sound. What that will sound like, nobody knows, but you could, in theory, draw out audio this way. Now, we're not going to do that, though. This is only one step of the pipeline, right? So if we go back to the order of operations here, right? We did this. Oops. We did that. Oh, that's so satisfying, you know, to go through a checklist and actually say, yeah, I did that, right? So now we're here. We did that, actually, so it's done. My bad. Okay, now we need to get the other model working. So if I go back to our picture here, right? Remember, this is a 3-step process. This step is actually going to be done by WaveGlow as well. And because I've already gotten this side working, I'm just going to assume this side works because I had scripts to make this work. Right? So we're just going to kind of ignore this side. We got that part working. Right? So the only part we're missing is the part in the middle. So if you remember, we're taking audio, raw audio, turning it into a spectrogram, which is a picture. Then we're using a picture style generator to create a different picture and then sending that back into audio. Okay, so let's get this part running. To do that, I need to get some files first. So just bear with me one moment because I need to open my Linux volume, which is home. Yeah, so I'm doing all this off screen because I don't quite know where everything is. but it should be under, let's see, ML. Yes, here it is. Okay, I'm just gonna make sure this is correct. Yeah, that looks like it. Okay, so I'm going to copy everything except, do I want results? Yeah, I probably don't want results. So I'm just gonna copy everything here. And how do I copy this? Okay, so I will show you what's going on now since I found it. Okay, so this is just a different program that lets me read the Linux file system, which is, you know, so I kind of, this is kind of like total speculation, but you know, I suspect that Windows, despite having like support for Linux now with Windows subsystem for Linux, I suspect they don't want it to be that easy to actually use Linux. So you know, traditionally, you know, Linux tends to have a lot of basically utilities for, you know, interacting with Windows file systems. So like these days, you can just mount an NTFS, that's the Windows file system, an NTFS drive in Linux, and it just works out of the box, right? At least with Ubuntu, which is the flavor of Linux I use. Unfortunately, it doesn't work the other way around. So in Windows, they've never had compatibility with the various Linux file systems there are. Right? So that's why I'm using this third-party program to actually open up my directory. And I really should have copied over the stuff beforehand, but I just didn't get around to it. I forgot that I had to, basically. So here's the thing I want. I just need to copy it over to my Windows file system now. So let's see how I do that. Yes, I can just save. Okay, so that's how we do it. So I can mount it, or I could save the files. Let's just save. So we're just going to copy them over. And we need to pick a place to copy them to. I would ideally like it to go to... I would like to go put it into my Windows subsystem for Linux, but I don't see it here. So we're just going to copy it to... yeah, sure. Let's just copy it here. Holy crap, there's 34 gigabytes. So let's mount it. So mounting just means, you know, you load it onto your, your OS, your operating system is able to see that directory now. So we're gonna do that. Oh, it doesn't let me. Okay, I see why. Yeah, okay, that is fine. We will save them. I mean, it shouldn't take that long because all of these are internal. Like these drives are all in the same computer, right? And they're also SSDs, so they're pretty fast. Okay, that's fine. Hang on. Do I want the symbolic links? No. Do I want the file from the date? Nope. And I do, yeah. So I'm gonna skip the symbolic links because I linked to the training data. I don't want to copy that out again. The directory structure I definitely want, right? Okay, so that's that. Okay, let's go. Okay, and the reason why there's 34 gigabytes is there's about like 24 checkpoints in here of this model, and that's actually what I use to generate the voice because well, because frankly the model's kind of trash. And so in order to get reasonable results, I was digging through the outputs of all these slightly different checkpoints to find one that sounded the best, and that's why I've kept so many, right? So you can see it doesn't take that long because these drives are quite fast, right? But I'm going to need to clean up the data at some point. Okay, so while that's happening, let's go back to here. So where are we? We did that, we're installing. Oh, right, we also need to install requirements. So there is a requirements directory. So in a lot of these projects, what you'll see is that there's like, there's basically a file that tells you all of the Python dependencies you need to run it. And the nice thing about this model is that's all you really need. You need Python, and then you need whatever dependencies are in the requirements file. So we just need to install those, right? So I need to find that requirements file first. Let me go find that. One moment. Please stand by. Please stand by. Where is that? Where is that requirements file? So it's still saving. Okay, I'll just wait for this to finish because the requirements will pop up. Okay, and then after that, we need to run this thing. So that's actually what generates the style things, right? And then there's actually 2 more steps. We need to record some test samples. Convert the test samples into the format that we need, which is the spectrograms. And then profit. Okay, so we'll say so 3-step process, right? Okay, looks like we're done. Yes, we're finished. So voila, here's all the files. And in fact, I think we can just copy it straight into Windows Subsystem for Linux. Yeah, so I'm just going to take this into here. Oh, might take a little bit to move all that. It might have to transfer because it's going from the Windows side into the Subsystem for Linux side. If I had known that, I probably would have done things differently, but that's okay. The important thing is, while it's doing that, I should be able to where's that? So I'm looking for that requirements file now, so I can actually install things. Here it is. Okay, we finally found it. So voila, that's everything you need. So let's do that while we're waiting for everything else to copy. So back into our handy dandy shell, we've already run this. I'm just going to leave this container open. So remember, this is the Docker container, which is a computer within a computer. We need that later if we're going to do the whole generating process. So I'm going to actually let's split this screen. Right? So the top left corner is going to be the Docker container. Down here we are going to go back into our main folder, and here's the stuff we want. So this is the style transfer model. Here's all the files for it, and the one we want is requirements here. So let's take a look at it. There it is. Okay, so those are everything you need, and that's a big list, so it will take a little bit of time to install. Let's do that now. Pip install, and -R for file, I believe, if I remember this correctly. Oh, before we do that, actually, I forgot. Always create an environment. So basically, Python is really nice. Well, actually, it's not really nice. Environments are a pain, but one way to manage different versions of code that could conflict is you create an environment, which is basically like another container, right? Except this time, instead of being like a Linux container, it's a Python container for Python code. So let's see. Currently, I have this MLTorch environment. We're just going to create a new environment. Using this command, virtualenv, for virtual environment, the Python we want is Python 3, because there's 2 versions of Python, right? Python 2 and Python 3, and we're going to give it a name of, let's call it Cohen approach. Okay, great. Okay, so it created that. Now we need to activate it. Apparently I do not have the command for that in my history, so I just need to manually find it. I think you run that. Yeah, okay. So now you see this little bit, that just tells you what environment you're in. Okay, so we are in this environment, which is its own little container for Python code. So now that we're in this, we can go back to where we were. This is the that style transfer model, and now we're going to install requirements, but into this environment. Right, so anything we install in this environment is like it's like going to Vegas, right? You know, what happens in Vegas stays in Vegas. Whatever we install here will stay in the environment and won't pollute, you know, the rest of our installation with stuff that could break, right? Everything can break. That's what I've learned working with computers. So first we need to upgrade pip. Oh my gosh, I don't remember how to do this apparently. Okay, let's find out how. Pip upgrade pip. Right, I remember now. It's like this. Okay, so pip is just the Python package installer. So you upgrade the installer before you upgrade everything else. Now we install everything in that file. Okay, and there we go. Okay, there's an issue. This requires Python 3.6. What version of Python do I have? 3.8. Ah, okay. So there is something inside here. This is C Python, I think, and it requires, you know, okay, so this is the kind of thing that having environments is trying to save you from, right? So we've got a version of Python which is not compatible with something that we need inside here, but my question is, why do we even need this? So C Python should be Python using a C backend. I'll just double check that. No, it's C extensions. Interesting. Okay, maybe we need that. It's really hard to tell, right? So the way you generate those kinds of requirements files to begin with is it just takes everything you've installed up to a certain point, and it just saves everything, right? So it's not clear whether this is a direct, you know, something that you really need, or it's just something that, you know, was installed by something else and we don't need that exact version. So in the spirit of being rough and uncareful, we're just going to remove that from the requirements, and hopefully that works instead of actually trying to install something else. Okay. Let's try that again. Cycler. Cycler also requires Python 3.6. You know, there's one other way to do this, which is we just don't install anything and we see what breaks. That is also a perfectly valid way. Actually, it's a terrible way, but it's also fast, and it's probably faster than trying to install Python 3.6. So let's take a look. If I just try running the model, sounds crazy, right? We're just gonna try running it, and whatever errors show up, we're just gonna fix them as we go. Because, you know, this isn't rocket science. We're not trying to do something reliably. We're just trying to get it to work, right? So let's do that. So I need to find the script that I use to actually run things. It's probably one of these, right? Let's see, main. So it's running main. It's generating this. I mean, that looks yeah, it looks kind of like it. The reason why I don't think it's quite right, these are the things I was using. So I have a whole bunch of different scripts, because some of them I use to basically run multiple checkpoints. And the whole purpose of this was, remember I said this model is not very good, and I need a lot of different tries to kind of pick out reasonably sounding results. So what this would do is just automatically call every single checkpoint I have, Yeah, this is the one. Okay, this is the one I want. So if I can run this giant mess of a file, then I've installed everything I need, basically. So we're going to try running it, and whatever breaks, we're going to install. Easy. Okay, so first we need to make it actually run. So we need to give it permission. Okay, and then we run it, and then we see what happens. Looks like we are missing results. Are we? Okay, so we don't have any of the checkpoints apparently. Oh, I probably changed the directory of where the checkpoints sit. Yeah, that's why. Okay. Here. Okay. So I just renamed some folders at some point, and I need to change it back, right? So right now it's looking in results / this place. And where do we want to look? So I'm just gonna switch over this new folder. Sorry, this new window here. Incidentally, how do I clear a window in Tmux? Control L. There we go. Okay, very pretty. We are going to go to here and basically pick out where our new where our results are hiding now. Results. Okay, so this should be where my checkpoints live. And it should be under model. Yeah. And I'm just going to check what is in done models. Yeah, nothing. That's good, because nothing's done right now. Right? So this is the directory with all the models. Right? Okay. And that is called this right here. Okay. So let's go back to our other window where we've got that script open, and it says list everything in results / this thing, which is out of date. So let's change that to results November 2020. Okay, that should work now. Okay, let's give that another run. Okay, now there's a big mess because it cannot find torch. Good. So we're making progress. Incidentally, maybe... No. This is fine. Okay. I was thinking maybe I should not run this whole script, because it's going to try running the same thing like a billion times. But sometimes it's better to stick with something that works, and instead of trying to jerry-rig something else that you might not know if it works or not. So first thing we need is torch. So let's pip install torch, and torch is just PyTorch, which is basically the thing that lets you run deep learning projects. So there's a couple of these packages, and there's, let's see, PyTorch, TensorFlow, JAX, but really I only know how to use PyTorch right now, so that's what we're using. Torch 1.12 is quite new compared to what we have, so I don't know if it'll work. Well, let's give it a try. What's it missing now? Traceback. Import itself. Import image. So we need PIL now. Now, I don't remember where PIL is. This is the Python image library. So we're just going to look in requirements. Yeah, see, it's not under this name. That's why it's a little hard to find. Let's just look through the requirements. Here, Pillow. Pillow's the name. It's really confusing. So there used to be a PIL library, Python image library, and then they changed the name at some point to Pillow because I think the original code stopped getting maintained, and then somebody else picked it up. Yeah. So let's install that. Pip install Pillow. Sometimes I wonder if a non-coder looks at these things, do they think we're just insane? These are just arbitrary random words. Okay, so now if we run it again, we should have some other error. Let's see. It's trying to find torch vision, so now we need to torch vision. And eventually I'll have installed everything that I need, right? Okay. SciPy import MISC. So I need SciPy now. It's the scientific Python package. Okay. And now what are we missing? CV2. CV2 is the open CV library, and this is another one where they changed the name at some point. Python import CV2. So it's actually called OpenCV Python. And the reason why it's called that is probably because OpenCV is a C thing. So it's actually written in C or C++. And so the Python version is just one of multiple. Wait. But still, I mean, I think it's really annoying. Everything's a different name, right? I mean, if after installing all of this it still doesn't work, I'm going to just install Python 3.6 and give it a go that way. Hopefully it does though, because I don't think we're relying on things that are like really new or different. Because generally when the software updates, you know, it sometimes breaks backwards compatibility, but oftentimes it will work with past versions. So we're just kind of crossing our fingers here. So now we need pandas, the Python data science library. Pip install pandas. So we have got pandas and pillows so far. Okay, let's take a look. Import torch. What's the error here? It's a little hard to tell. So it's trying to import torch. It's trying to import NumPy and JSON. Huh. From oh, okay, here's the error. From melutils import star. So this is actually something I put in, right? So it's just like a helper function. So it should be under oh, I probably changed the directory name at some point. This is the danger of renaming things to make them make more sense. Sometimes you just break things. So it should be here, yeah, it's under Volclone Tools, melutils, right here. So it should be in there. We just need to make it visible again. So we can finally edit some code, I think. Okay. Let's open up Visual Studio Code, my preferred editor. And we are going to open a directory, which is this one, yes. No. Let's open, yeah, this one. Okay. All right. Yes, I trust myself. Okay. So actually this is the file we were working at earlier, right? This is actually much prettier. I should have done this sooner. So, let's see. We've got, here's the tools, and the one we want is this one, melutils. And currently it's calling main somewhere here, yeah, and it's importing this thing. And this thing is trying to import melutils, you can see, and it can't find it because it's been moved into this directory. So the easiest way to fix that is to copy it out, but I'm afraid this might rely on some other things. So I'm like, let's take a look through here first to make sure that it's not going to need something else in this particular directory, which it doesn't look like it does. So one way we could fix this is just move this file into the main directory. And if that doesn't work, I'll massage it to make it work. Okay, so let's just try that. Okay, now it can't find something else, so that's good. We're making progress. Module not found, iterseek. What is iterseek? That looks like another thing that I created. Yeah, here it is. Okay, let's copy it out. So I'm kind of glad I'm doing this because it would have broken regardless of whether I installed 3.6 Python or not, because those particular files I created are simply not in the right place. Okay, so we are making some progress, I think. Yeah, it's printing out more stuff, so that's a good sign, right? You know, this is getting annoying. It's a little too small on this side, so let's work on the right side instead. One project, you got it. Okay, there. Okay, and we were running. Oh, we need the source. Oh. Need this command. Almost that command. Okay, so we are back in our environment, our Python environment, and let's run this thing and see what it does. So it tries to get somewhere, and then it runs into an error. So you can see, let's see what's happening. So it gives you some information. First thing it gives you is all of the things that it's been called with. This is all the command line arguments telling it what to do, and then it's printing out just some data about what's getting run. Okay, that's fine. Wait. Okay, now here's where things get interesting, because it says it's trying to build a model, okay, and it's trying to pull in some kind of stuff. It's trying to find this data, but it can't find it. Okay. Okay, so we're just missing some directories and links here. Number of epochs must be larger than or equal to 1. Okay, that's not important. The important thing is it cannot find stuff. So what is exactly in this data set Cohen with interview place? Let's find out. So nothing, because I did not copy that over. And that should be fine. I don't need the training data because it's already trained, right? It just really needs these directories to exist, I think. The good news is it looks like we've installed everything we need, so it should run so long as it's finding the right directories somewhere. So let's just take a look at the code again. So the error is on line 225. So let's pull up the actual code here. Line 225. Oh wow, that's such a mess. That's really hard to read. Okay, I'm just gonna highlight it here. In yougotit.py. So we're gonna open up yougotit.py here. Okay. And it's line 225. So let's go to 225. Okay. So I see what's going on now. So in build model, it looks like it's just initializing everything, even if it doesn't need it. So you can see the train A is looking in this particular place, and it needs all of these, even though it's not going to use these things, right? It still needs everything here. So that means we just need these directories and it should work. Should, keyword. It should. Okay, so let's just create those directories. Right, so we are under, you know what, I will use the shell because it's a little bigger and easier to see. But because this thing's a bit messy, let's create a new one. Okay. Yeah, I'm not a tmux wizard, so When things get too complicated, I'm just going to use the graphical user interface that I have. Okay, so we're going to go back to Cohen project. Yeah, okay. And we need to go into results. No, sorry, data set, because this is where it's looking, right? And so you can see it's looking for dataset self.dataset. So this is an argument from somewhere. We can find out what that argument is back in the error message we got. So the error message said, well, actually, if we jump up a little, it says it's looking for the data set called Cohen 160 with interview. So that's the one we want. Yeah. Okay. So let's copy that and make a directory called exactly that. Okay. Oops. Okay, there we go. Took me a couple tries. I'm in that directory. Now we need all of these directories. Train A, train B, test A, test B. Wow. I think that's it. Oh, and one more, noise. So one of the things that was really difficult about doing this is most of the time when you're trying to do style transfer, right? You have clean data. But the problem is, I don't have clean data here, right? If you think about it, the whole point of style transfer is you're trying to make it sound like somebody else, or make something look like something else. Well, I don't have Leonard Cohen's voice on its own. I only had recordings, right? Because I'm not Sony, or one of these big companies that does the recordings. I don't have their original tracks, right? So all I have is this complete mess of like background and vocals and other vocals, and sometimes there's like audience clapping, all this random stuff going on. And what I really want this model to do is copy Leonard Cohen's voice specifically and ignore everything else, right? And that generally doesn't work with these models out of the box. So the main innovation I tried to do with this model was to be able to separate out the noise from the actual audio of the voice, right? So it would try to ignore the noise, and the way I did that was using something called noise injection. I basically stuck the noise into my training data, even like the source data, so that's my voice, right? I would put this background noise into my voice, and so hopefully that would make the model kind of ignore the background noise, and it kind of worked, right? So the end result was kind of okay. So anyway, have I made all the directories? I need one more for the noise. So these were important for training, but really when we're doing the testing, when we're actually just running it, we really only care about two of these, which is test A and test B. And basically the model is going to take anything in test A and turn it into something from B. And in this case, A is like my voice and B is Leonard's voice. And so we're basically going to take any sound that looks like this and turn it into that, and vice versa, right? So I think we just need to fill out either test A or test B. I forget which one it is, but let's see if it runs first. So let's go back. We just need to make sure everything runs first, right? So clearing it all, we're gonna run this again. Okay. I mean, something else is happening now, right? Let's see what is happening here. Let's see. Okay, so starting, it's running, and then it runs into an error here. Found 0 files. Okay, that's good, right? That means it's actually trying to look for files in test A now, and it cannot find any. So of course it cannot generate anything, right? So we're really close because now I think all we need is to bring in a file that we want to convert, and it will do it. So we just need a spectrogram file now. So let me dig around for a spectrogram file because I have this stuff somewhere. Of course, the problem with projects is, you just store them in some directory, and when you were working on it fresh, it was obvious where it was. But after a while, you forget where everything else. So this is what we need to fill up, test A. And I just need to go find where this file is living on my computer. It doesn't help that I'm trying to do this on a different setup basically than what I had. And so everything was working on that particular Linux setup, and now it's not. Okay, so data, Cohen. Okay. Voice in, voicemail, voice norm. Okay, this looks good. I think this is it. I really hope it's the right size, but we'll try it. I mean, if it doesn't work, it'll just break. It'll just raise another error, and I mean, we've been there before, so that's nothing new. Okay, so I've got this. I'm gonna copy this over. This is the name of that song I wrote, and this is what I was trying to do. This was the whole point of the project, was to create these sounds. Okay, let's give it a try again. Still causing an error. Let's see what's going on. Still finding 0. Oh, it can't find anything in test B. I see. I mean, let's just copy over the same file. So I'm just moving the same file over. I just want it to run first, right? And then we'll figure out what's going on. Okay, it's still causing issues. Oh, okay, I see. So one of the things I did was I was trying to seed the generation with a little bit of extra audio so that it would sound consistent every time I ran this thing, right? Because the way this works is it kind of generates audio in little chunks. And the problem with that is when you go from one chunk to another, it sounds really terrible, because there's a big split between them. And it doesn't know, the model doesn't know that you move from one chunk to another, right? Because it's only looking at like a little square image at a time, which is like maybe 2 seconds of audio. So to fix that, I introduced a little bit of seed audio, which it was just using to make things more consistent, because every time it generated, it would have that seed audio in the source, so it would have to kind of match up the sound. Yeah, so I just need to go find the seed audio. I have it somewhere. Okay, let's go find it. So this is in my other hard drive. Okay. Okay, I should just look here. This is the original, right? This was working when I ran it. So let's see, you can see all of these. These are the exact same folders, but they're full of stuff because this is what I was training it on, right? So you can see train A, train B. We don't need those though. We only need test. So you can see test A. Okay, that's good. Test B. So test B is where I want my voice, and test A is where I want the other stuff. Okay. I think. Okay. I think that's true. So let's try it. Well, I'm a little confused by why it's looking for the seed and it can't find it. That's a little weird. So let's just take these two and save them out. Okay, it's done. Let's copy it over. Let's copy things over. So test A, test B. Okay, so if I search here again, we are looking in, let's see, looking here, right? Okay, yeah, there's stuff in here, right? That's good. But the problem is, I think it's looking for something else. Well, let's just try running it first and see what it's looking for. Yeah, so it's looking for a file that it can't find. Which file? It's probably looking for a seed file, right? Yes, so it's looking for the seeded file. And I don't know exactly where that is, so I'm gonna have to search for it. I mean, I could just name one of these seeded, because it basically, whatever the seeded thing is, it's just going to use that as like extra audio data. So I could just rename one of these files. So let's go into test A. And we're just going to rename this guy to whatever it was looking for, which was this thing, seeded gen this guy. Okay. Oh, it's looking in the main folder. That's why I couldn't find it. Okay, never mind. Step back. Let's look for that seed. Is there a seed? There is not. Ah, it's looking in results. Okay, no wonder I could not find it. Here it is. That's where it's looking, right? Results, Cohen 160 with interview. Here it is. Seed image Mel. Okay, that's the one we want. Let's save this out. Someday we'll get this done. Okay. Okay, I've got everything in the right place now. Let's try running it again. And what's the issue now? Strided loader. Value error. Math domain error. Oh, it's the wrong name, of course. Seeded gen. So I just have the wrong name for this file. So let's rename it. Gosh, this is awful, isn't it? Okay, so let's clear this. We're gonna move back a couple directories because we need to go to the results. And then, yeah, here. Okay, so you can see I copied this over. That's the thing we want, but we need to move it. Okay, and while we're here, let's make sure that we actually have a model checkpoint. Of course, they're not here, so I actually need those model checkpoints back. Oh, okay. Okay, so I see what happened. Okay. So at some point I renamed this directory, this guy, which contains all of the models that I need. Yeah, so let's just move that back, shall we? So, or we could change the, okay, let's do it the proper way. So I'm going to change the arguments for this command, this script, so that it actually pulls things from the right place, right? So we are going to rename this to Nov 2020, because that's where we're pulling from. And we also need to move the data directory. Data sets. We are going to move this. Well, we're going to change directory to there. Yeah, let's change directory to here and then move. So it's just housekeeping to, you know, get everything with the correct name. November 2020. So you can see when I actually built this model was 2020. Yeah, that was a kind of stressful November because I had a whole bunch of exams and things going on at the same time. I think I was taking algebra too, and this is like abstract algebra, so it's basically the most horrifyingly difficult thing, at least for me. Yeah, abstract algebra is like the funny thing is when you get a textbook that's called elementary algebra, you think, how hard can that be? And then you open it up, and it's, you know, it's math broccoli, as one of my professors would call it. Just insanely difficult stuff. Yeah. So anyway, we are, let's see, 2020. I mean, we've got everything in the correct spot now, so let's try running it again and see what it's missing now. Yay, progress. So it is, it's getting further, I think, and it's trying to find Chardet, which I have no idea what that module is. Although I'm a little suspicious that's still looking at this directory, so I might not have changed everything correctly here. It's back here. Okay, that's fine. We don't want to move anything right now, so we're just gonna leave those. Okay. Now, so the important thing is the error that happened before that, which is let's see. Number of epochs must be larger than or equal to 1. That's the issue. Okay. So I'm guessing it's trying to load a model, you know, a checkpoint, and it can't find it. That's probably my guess. So let's take a look through this. What a mess, right? You know, they say research coders make the worst programmers, and I think it's true. You know, so this is like crappy code on top of crappy code, and that's usually how you get things done. Math domain error. So let's just look at the code. So it's main file, line 138. So let's just jump there. Main file, line 138. Main 138. It's running build model. Okay. So we jump there. Line 229. So this is right. Okay. So it's going here. Okay. So let's jump there. Okay. Line 98. Here. Okay, so this is where it's breaking, right? Probably. So it's taking the logarithm of something, and that thing is 0, so you can't take the logarithm of 0. That's the issue. So whatever this is whatever this is 0 right now. Why is that? It's the number of sequences, right? So my guess is it's loading something that is too short. It's loading some kind of spectrogram that is way too short, and so it can't solve it. Okay, that is something I can deal with, probably. Let's see. I need to do this. I need to know what it's loading here. Oh, it's the train stuff. Okay, so okay, I see what the issue is. So even though it doesn't need the training data, right, it's still trying to load it because that's just what the code tells it to. Now, right now I have no training data because, well, I thought I didn't need it. So I'm just going to copy over some fake data, and hopefully that kind of fools it into behaving, right? So let's go back. Oops. Let's go back to here, and we are going to just wait. Sorry, I'm getting mixed up with all my windows. So this window is the dataset side. So we need to go through the dataset here, and we're going to just create some fake data here. So you can see that right now, if I look in noise, for example, there's nothing, right? And so it's complaining because they can't find anything. So we have something in the test directories, of course, right? Like that. So we're just gonna copy, we're just gonna move over some of this stuff. We're gonna move this to noise. Right, so now if I look at noise, I've got something. Hopefully it won't complain anymore. So let's take a look at also, I also need to do the same thing for train, so train, okay, I don't want that there. Yeah, so I'm gonna move this to train something. I don't really care where. Okay, and then I'm just gonna copy the same thing into train B. Actually, let's look here. Everything. So now noise has something, test has something, test has something. Oh, hello. Cat alert. So I've got 2 cats. And I see one has come join me. Would you like to code with me? Is that what you're here for? Okay, I guess you can code. Do you want to sit here? Yeah, sit there. So, yeah, let me show you. There's the cat. Yup. Okay. What are you doing? Okay, she's sitting now. So we can get back to work. She's not sitting on the keyboard. That's good. Okay, we're gonna try running this again. Oops. That is not what I wanted. There. Okay, that's promising. No error yet. That's really good. Oh, then there's an error. Okay, so it almost got through it. We were so close. This close to greatness. So, let's see what happened. I cannot find where this, where did the last one end? Okay, I'll see if I can catch it again. Here. Okay. So, oops, sorry. I'm knocking this mic. So we're going to start here. That's where I ran the command. Okay, this is where we got. So it's printing stuff out. Useful stuff, presumably. Test. Okay, so this is all diagnostic nonsense. Don't care about it. What we care about is the error that happens after. So it says it cannot find this file, which is, okay, it cannot find this model. That's the issue. Why is that? Now that's a little strange because it's using the same interface to look for models. So it should be able to find it. So let's take a look at what's in that directory. It's results and then whatever that is. Okay, so results, November 2020 model. Okay, so here's all of my checkpoints, and it's trying to find this one. Okay, I see what the issue is. Go figure, there's always an issue. So the problem is I renamed the directory, but all of these checkpoints still have the old name, and it's looking for the old name, not the new name. So we gotta change that. Let's just rename everything, I guess. Yeah, I think that's the easiest way. Okay, see if I can do this correctly. So we are going to loop over do echo. Let's just make sure we have the right thing first. So I'm just looping over every file here, and making sure I have them. Okay, that's good. Now we're going to rename them. So instead of echoing, we're going to move. Oh, that's not going to work, is it? Yeah, if I was better with the shell, I would be able to do this very easily, but I'm not. Usually I just rely on the file browser to do it for me. So let's see. Is there a way to do this? I think there is. There's always a way, especially when you just Google the problem. So yeah, look at that. Stack Exchange always comes to the rescue. Ah, well, that's easy, isn't it? Wait, no, that doesn't work. Okay, that's definitely not the right answer. Yeah, we need to match a pattern here, right? You know, all of this would be much easier if I just renamed my November 2020 back to what it used to be. And maybe that's the other solution. Okay. Yeah, so this does work, but you know, let's just stick to the simpler solution. We're just gonna rename the directories instead, because that's easier, right? We need... Is that correct? I think that's correct. Same thing. And the last thing is we're going to need to edit this back to what it was. Okay. Almost there, so bear with me. Results. Paste. And here. Also paste. Okay. Can't find things anymore. What? Ah. I cannot find anything here. Why not? Results. Cohen 160 with interview. Yes. There is nothing in there. How strange is that? Okay, things are getting a little weird. So I moved things over. Oh, okay. I accidentally moved it into the directory as a subdirectory, no wonder. Because it already exists. Okay, that's easy enough to fix. Sometimes you just gotta do things using a GUI. Okay. I think that's it. Just doing a quick sanity check here. Let's try it again. Yes. Okay. We're so close. It's running, it's testing. Okay, so it should be running through each of these. Yep. It's loading a checkpoint, generating the output, so that's the gen finished. right? And that's doing it again, basically, with every single checkpoint. This takes a while, as you can imagine, but once it's done, we should be able to see the results filling up. So let's check there. We're going to go back to the results directory. And let's see, it should be under something. Test? Where is it saving to? Oh, it's probably saving to... Where is it saving to? That's a really good question. Where are you saving to, my friend? So, I mean, good news, it's working. Bad news is I don't remember where it's going. Image, okay. It really should be saving to test, but it's not. Okay, so once each checkpoint is done, it's copying, or sorry, moving it over to done models. So that's good. Oh, it's in done test. There it is. Okay, we did it. So what we have here is these are the files that are getting generated. And if I search through this directory again, I think you will see some extra ones show up as they finish. Actually, if I check the time these were generated, it should tell us. We have November. Okay. It's a little strange. Okay, never mind. These were generated a while ago, so these are not the files we are looking for. Huh. I mean, it's doing something. It's going somewhere. Where, we do not know. Okay, this is where we need to dig into the code a bit more. So let's look at the code, which I haven't looked at in 2 years. It might as well be written by somebody else at this point, and figure out where it saves to. Torch.save. Yeah, so I should be running this c2gen thing, and it says torch.save to final. This is the thing it's saving. Okay, and this is where it's saving to. Ah, okay, interesting. Okay, so it's saving to results. Okay, and then I'm guessing, because it's always saving to the same place, and I'm running this multiple times, I need to copy it out after I save it out. So I need to go back to the shell script, which runs all of this, right? So it's running a loop over every single checkpoint, and then after it generates, it says it moves whatever was generated to this place. Okay, I see. So it should be under presentation. Let's take a look under presentation. And let's take a look at when these files were created. Oh, that's good. So it's September 10th and this time. That's good. Yes, because that's right now. Hey, look, we've been doing this for 3 hours, but it looks like the end is in sight. We've gotten both pieces working. And looks like, yep, it's working. No errors. Well, that's exciting. So it's kind of moment of truth time, isn't it? We need to put it all together. So let's just kind of go back to our project tracker. We did that. We installed stuff where you got it. We ran that. So let's done. convert test sample. So we're here. Hey, we're so close. Okay, so just as a quick recap, we got the model here, we got the model on this end, we got the model in the middle. We just need to run this whole pipeline now from start to end, and then we're done. Okay, so that's really awesome. Okay, so now we need to do a couple more things, and then the magic will be here. So let's do it. We need to, let's see, record something, convert it into a spectrogram, run the style transfer. That's this model that we just finished setting up, right? And then run wave glow to turn it back into audio. Okay, great. So let's record some test samples and give it a shot, I guess. I'm just thinking, like, have I missed something? You know, sometimes when you've been in the weeds for so long, you start wondering, like, did I miss something? Did I cover all my, like, bases here? Did I check my, you know... okay, yeah, that's fine. I'm just gonna clean up a bit because I've got about 10 different things loaded. Hi. My cat's trying to cover my screen, make it impossible to work. You wanna move? You wanna move? Okay, goodbye. Okay. Alright, so let's see what's going on here. I'm just cleaning up everything that's on my computer. There's about 1 billion windows right now. I don't think we need that many windows anymore. So let's close up that. Okay. Nice. And I don't think we'll need to look at this. So we can close the code. And now, okay, we just need to do this. So, step 1, record. So I just like to use Audacity because it's free and it's easy. So you can just record like this, testing, check. You can just record like this, testing, check. Okay. Cool. And let's do some fun things. We'll do maybe like a channel opener, you know? So, you know, like what would I like Leonard Cohen to say for me? Maybe like welcome to average expectations. Let's try that. So I'm just gonna turn down the audio for a sec, the music, so I can record. Welcome. Do I want to say welcome or hello? Let's say hello. Hello, hello. Welcome to average expectations. Hello, hello. Welcome to average expectations. Okay, so we'll just try that to start, right? And I'll leave in the test bit, because why not? Okay, and we'll turn the music back on. All right, so I'm just trimming out the cruft because the less you have to generate, the easier it is on the computer, right? It just takes too long otherwise. We will normalize this just so that's reasonable. So I'm just rescaling the audio waveform so it's kind of same volume throughout. Okay, and we just need to export this. We need to export as WAV. So basically there's a lot of different formats for audio. WAV is uncompressed and those files are huge, but we want huge files because that's the only way you're going to basically, because it's uncompressed, the computer can read those files directly, right? So my code does not work with compressed audio. Okay, so now we've got our wave. We'll call it stream test. Okay, and we are going to move it into. So there's a couple steps to this pipeline, right? We are here, and we need to get to here. And to do that, it actually takes quite a bit of processing because if I remember correctly, there is some kind of script that does that. There are so many scripts, right? Scripts within scripts. Let's just clear this out. And let's clear this out, because I'm not running that right now. Okay, so we are going to use the left side for wave glow. So let's move to wave glow. Okay, and one of these will generate the thing we want. Checkpoints, the train files, yada yada yada. It's one of those cases where I know there's something that lets me do this, but it's been a while since I did it, so of course I don't remember where anything is anymore. But I might have left myself a little breadcrumb trail. At some point I created a shell script that actually runs everything, I think. So yeah, this is why people say you should document your code, you know, write comments and stuff everywhere, you know, write readme files, because otherwise you can't possibly remember what you were doing, you know, 2 years ago. Let's look in here. All in one. Yes, this is the one. So I know this file doesn't work, but it at least tells me what I should do. So it's a big mess, but it says you should run resamplewaves.sh, then make intervals, then wave to mel. Wow, that's a lot. Look at that mess. Holy crap. Yeah, okay. So I don't need all of this. Some of this was to process the training data. Obviously we don't need that. Rough split. Make intervals. Make intervals. I don't think I need make intervals. Make intervals was to split the data. So I had training data, some of it had the voice of Leonard Cohen, some of it just had background vocals, and basically I had created these masks which would kind of let you split out the parts with the voice and the parts without the voice. And so I had to create this split in order to split the training data into the training data and the noise data, which I was going to use to augment my voice in order to make the model ignore the noise. So yeah, a lot of this was to create the correct data for this system. So I don't think I need all that. I just need the stuff that creates, yes, here, make mels, you see, down here. We've got, okay, so I think I just need to call wave to mel, this script, and it will take whatever is here and make it into the spectrogram, and the 160 just tells you what the resolution of the spectrogram is. And these models, you know, they're hard coded to a certain size. So in this case, 160 is what we need. Okay, so I just need to run that. Let's look for it. I don't know where I put it. Oh, I probably put it here. Actually, no. I'm going back. I think it's under here. Yes. Mel to image. Right? Wave to mel. Sorry. Wave to mel. Okay, I do not have wave to mel here, so I do need to go. Here, wave to mel. That's the one we want. Okay, so let's take a look at what's in wave to mel. And I'm just leaving this open so I, like on the right side, so I know what I should be inputting into this. It's like archaeology, you know? It's like code archaeology. You're just digging into the past and trying to figure out what the heck's going on. Okay, let's take a look. So it converts everything at this place. So these are arguments from the command line. First argument / second argument into first argument / third argument with 4 channels. Perfect. That looks exactly like this, right? So here's the first argument, your base directory. And then here's your second argument, that's the source. Third argument is the target. And the fourth one is the number of channels in your spectrogram, so the size of your spectrogram. Okay, and I think that's all you need. Right. And yeah, okay, so we just need to run this. Okay, where did I put that data? ML. Oops. Okay, so I just need to go find the data I want to convert again, which is... Oh, right. I just generated it. It's literally the file I just copied in. That recording I did. Where did I do that recording? I put it here. Okay. I put it on the desktop. So we are just going to stick it into Cohen project. Okay. So now if I go back to home, there it is. Wait. There it is not. Here. There it is. Okay. So this is the file we want. We will just create a couple extra directories to hold everything. So the base directory will be this directory, and the rough split will be, we'll call it, let's make dir. Inputs. Okay. Okay, we're just going to create some directories just to separate everything out and make it reasonable. So we need a base directory, which we have. We need a source and a target. So let's create that. Source. Null target. Okay, and we're going to move this the actual audio file into wave source. Okay. Good. Now we're going to go back. No, that's not where we wanted to go. Okay, because we need to run this wave 2 mel. Oh, let me guess. It is. Oh, oops. Oops, sorry. I meant to go there. Okay, there you go. So now we can run wave to mel. Looks like I need to add execution privileges to wave to mel. Okay, now I can run wave to mel using the base directory is our home directory, Cohen project, inputs. Then, so we're just copying this format, right? So we have got our base directory. Our output directory is a subdirectory of that. So this is a little weird, but it just sticks this onto the base directory. So I do not need to repeat that. I just need, what did I call it? Mel target and wave source, right? Wave source and then mel target. Okay, almost there. Last thing is the channels. Yeah, let's hope it works. Or it doesn't work because it can't find this. Okay, that's easy. So it's because I used to have this symbolically linked. So it was shortcutted to here. So I just need to create the same shortcut and it will be able to find it. Right. Okay. You know, the other option is to change the, yeah, let's just change the script directly. Okay. So it's just trying to run this guy, Python, ML, Tacotron, preprocess, blah, blah, blah. And we are just going to make it a relative link. So it's going to go, or let's just hard code it. So currently, where are things? Currently we have Cohen project Waveglow. It's under here, right? Yes. And the thing we are trying to run is called preprocess audio, which is right here. Right? Okay, yeah, so we just need to send it this link instead. So, where was it? Here. Cohen project Waveglow preprocess audio. Okay, that should be the right place. Ooh, there's one more thing I forgot about here. Interesting. Interesting. Okay, so it creates some CSV files, just text files, listing all of the inputs and outputs. I think it does that automatically, so we should be able to just run this now. Ah, okay, we are missing librosa. So let's run this inside, I think. Inside the Docker container we had earlier. Man, it's been sitting here for like the past hour doing nothing, and now it finally has a chance to shine because I think I have librosa here. Yes. Okay. So the reason why we need librosa is it's a audio file kind of managing. It's like an audio utilities library for Python. And actually, I think I will be using it potentially for my next project. So it's good to remind myself this thing exists. But okay, so we just need the same files, but inside here now. So how do I do that? Fortunately, right now it's not really here, right? Yeah. So I just need to copy some files over, I think. Okay. Easy enough. So I'm just going to do that. Give me one moment. We're going to copy the inputs into... Actually, I can do that. It'll be easier through here. CP wave to mel to Cohen project. Waveglow. Waveglow what? Let's just stick it in the same place. Okay. Is it there? Yes, it's here. Okay, good. Now we also need to move the input files, so let's move those. Where are they right now? I'm just gonna change directories back to and move the inputs to Waveglow. Sure, let's move it in here. I hope I didn't overwrite anything. That would be unfortunate. I mean, it looks good. Okay, so we just need to run it now with slightly different arguments because we're in here now. This is inside the Docker environment, right? So it's technically a different computer. So let's take a look here. We should be in. Okay, so we've got our inputs, and we need to run the script from here. So. Okay, and I'm just gonna bring up the same file again so I remember what to do here. Okay, so it should be okay. Base directory is inputs. The subdirectory is wave source, and then the output directory is mail target. Something like that. And 160. Oh, and I, of course, the location of the thing it's trying to run has changed too because I moved it around, right? So I think it's sufficient to just do this. Think. Okay, let's try that again. Inputs, wave source, mel target 160, looks good. Index error, huh. I mean, at least it's running, but let's see, we're looking for this. data loader.getMel. Sorry, I'm just gonna make sure I'm not going crazy here. Okay. Okay, so it's trying to do one file and something goes wrong halfway through. It says, so one of these numbers is definitely wrong. Now that is certainly a little weird, I gotta say. Okay, let's figure out what's going on here. I think I need to open this pre-process, whatever. Okay, let's try that. Okay, so we're going to open up pre-process. Okay, so it's just a little script. Yeah, this is a Python file. So it's a little Python script, and it's trying to, let's see, it goes to line 51, audio to mel, so here. And inside audio to mel, it's calling get mel. So trying to get the spectrogram, data loader. Okay, I see. So it's opening up this kind of audio paths and text list, and one of these indexes is getting out of range, right? So it cannot find something. So let's take a look first at what's in inputs, and specifically these CSV files, because they're supposed to tell you what to look at. Okay. Let's see. For I range length smell paths. Okay, so one of these is the paths to audio, and the other is the paths to mels. So those are the spectrograms, right? So I mean that looks fine, right? The issue here is the audio paths. So let's take a look at the audio paths instead. So that should be, where is it? Waveglow, pre-process. Okay, wave source, stream welcome test, that's good. That's what we want. And then on the other side we have none. What? Okay. Data loader get mel. So here's your list, right? So this should have given you, I'm going to open this in code. It'll be easier to debug, right? Okay. Time to go back to our good old IDE. And we're going to open this guy. Okay. So here's the file. It's just easier to look around because the nice thing is here I can click on this and it will send me straight to where something is called. So for example, if I called load file paths and text, you can see this is what it's actually doing. So it's loading this data set, path, okay, the file name, the split, which we have, the pipe, okay. So yeah, it should just be fine, right? Iron range of length, so this I should be 0 to start, right? So you know what, there is an easy way to do this. We're just going to print this out and see what the heck's going on. If in doubt, print statements to yeah, this is another sign that I've never been formally trained, because in computer science, you know, you're really not supposed to be using print statements to do debugging, but here I am using print statements to debug. So here, let's see. We've got, I mean, this looks good. It's giving me a list of two things at a time. One is the name of the file, and the other is this thing, which I forget what I used it for. It was useful for something. So something weird is happening though, because then it says tuple index out of range. Huh. Okay, so let's trace that. Line 51. That's here. And then when you call getMel, so I'm just going to do this. Yeah, okay. So we call getMel, and then we go to 69. Nice. And let's see. Raise value error. So this is the error that's coming out, I think. Tuple index out of range. So all it has is a file name, right? So the file name's fine. It's the sampling rate which is getting it, I think. We know it's getting this far, right? Yeah, I never thought this would be the thing that breaks it. Okay. Time for some debugging. Let's see. We've got getMel. Okay, we're just gonna print this because that's what we do. So audio should be some kind of torch file, but just in case it's not, I'm going to, yeah, this is a print statement debugging at its finest. So we're just printing the sampling rate, and then hopefully this is what I think it is, a torch tensor, and it will print that as well. Okay, yes. Okay, so here's the sample rate. Okay. Oh, I know what the issue is. Okay. All right, so man, I think my brother knows all about this one because when I sent him the converted, like the generated voice files, he's like, wow, there's no high end to this. You know, everything's like all the frequencies above 10k hertz, 10 kilohertz are gone. And the reason why is because this model only generates up to half of this sample rate. Right, so the first thing I needed to do with my original recording is actually convert it down to the right sample rate. And I forget what that sample rate is, so I'm just going to check. It should just be whatever the STFT, this sample rate is. I'm just going to print it out because I'm lazy. Okay. That's all I need, right? So let's go back and run the same thing again. Oops. Okay, it should print it out for me. It's not. Oh, that's because I somehow did not copy that over. Okay, try it again. One more time. Okay, here it is. So 22,050. That is the sample rate here. So yeah, that is half of the sample rate that I've recorded with. You can see the sample rate down here. The project rate right now is 44 kilohertz, 44.1, and what we need is half of that, 22 and 0.5 kilohertz. Okay, so we just need to, you know, hang on. How do you convert? You know what? I'm just going to re-record this at this because I don't trust that this won't make my audio go screwy. Okay, so we're just going to re-record at half the rate, and then it should work. Oops. So pause music, and testing, 1, 2, 3. Hello, hello, and welcome to Average Expectations. Testing, 1, 2, 3. Okay. That works. Hello, hello, and welcome to Average Expectations. Okay, maybe I'm gonna re-record this just because. And welcome to Average Expectations. And welcome to Average Expectations. I find the voice model doesn't work as well if the audio isn't very like loud and clear. So sometimes I mumble into the microphone. You're probably well aware of that now. So, you know, it helps to have a nice clear sound for the model to look at. Okay, so I think, yeah, that works. We're just going to trim off the extra stuff on either end because we don't need that. Okay, and is it clipping anywhere? I don't think it is, because I always hit Z. So in Audacity, when you hit Z, you find the nearest 0, and that helps reduce clipping if you're cutting things out. Brother's probably shaking his head at my pathetic audio editing skills, but there you go. Okay, and I need to export a WAV file, because that's the only thing that it will accept. Okay, so let's try this. It's amazing how much you forget after a year of not doing something, or 2 years. So we've got our new sample. We're going to copy it over. Back into here. Okay, it's back. So now here's our new one, untitled. We're going to move that into inputs, wave source. There we go. Okay, and we need to get rid of stream welcome test, so we're just going to move untitled over it. Okay, excellent. That should be the correct sample rate now. So if I run this again, let's see what goes on. Runtime error. Okay, we're making progress. It's a different error message this time. So that means progress. You can see some good stuff. We have a thing here. Okay, so we just need to jump in. That's a little weird. Oh, it's stereo audio. Okay, that's easy enough to fix. So yeah, oops, sorry about bumping that. I'm getting too excited with my mouse and keyboard. So the problem is, in addition to having half the sample rate you would want for audio, it also is only in mono. So I need to basically mix this down to mono. Okay, testing 1 2 3. So mono is just when it's one channel of sound, right? Normally we have 2 ears, so you'd have 2 channels of sound. Of course, I only have one microphone here, so that's all I'm recording anyway. Okay, we're exporting. 3rd time's the charm. So let's hope this is mono this time. Move untitled to there. Go back. Move there. Okay. 3rd time's the charm, right? Crossing my fingers. Yes. No error messages. That's when you know you have a good time, right? So we're going to look in the target folder, and there it is. So here is the spectrogram, finally, at very long last. And now we just need to send this through. So let's see where we are. Right. So I'm going to copy this again. Right. So we did this part. I'm going to draw a big, fat, transparent, reddish. Yeah, let's make it kind of like this. Okay, this tells us where we are. Okay, so we started with the audio, recorded that, and now we're here where we turned it into a spectrogram. Right? Now we need to do this. We gotta get the image generator going. So we're going to move this spectrogram over to where I was processing those images, which is here. In results or data set. I think it was in data set. Yes, here. Okay, and we need to put it in test B, I think. Yes. Okay, so we're going to move it to here from there. So inputs, mel targets, and we're just going to move everything here. And we can delete all the other ones. Okay, so now the only thing we have here in the inputs, the test inputs, is this stream welcome, right? So now we are going to run the style transfer model. So that was, yeah, just move back out a bit. That was this guy, generate on all checkpoints. And I don't think I need to do anything here because it's already been set up to work. So I'll just pull whatever's in there and generate with it. Oh, I forgot one thing. We do need that seed audio. And I accidentally overrode it at some point. So let's stick in the seed audio. Again, the seed audio just tries to make each segment that it generates more consistent with the other segments. So, where's that seed audio? Oh, I do have a seed image here. Okay, that's good. Yeah, that's the one. Okay, excellent. So we just need to run this now. Okay, running. And it's almost midnight, so I'm actually right on time. You know, this stream is supposed to be about like 4 hours, and looks like I barely managed to finish everything in 4 hours. Okay, let's make sure that it's actually generating the right things. Oops. Okay. It's a little strange. It's not sending them out here. Why is that? It might be generating the other side first. But that doesn't make too much sense either. Oh, I see. There's an error. Okay. Let's pause this. Take a look at the error. File not found. No such file. Okay, I must have removed some files at some point. Okay, so let's just go into that. Let's just fix that. It must be hard-coded to use a specific file, that's why. You know, when you're in a rush, you just hard-code things. You just put in file names directly into the code. And of course, instead of fixing the code, we're just going to hack it to work by moving the file to the right place. So, what's it looking for? It's looking for, oh, it's looking for this. Okay. Wait, no, that's because it's not generating. If it was generating, that would be fine. Okay, I see. So I just need to rename this to this guy, I think. Okay, let's try running it again. I'm just making sure I've got... Okay, we are just going to reset everything here. I'm just moving the checkpoints back to where they're supposed to be. Okay, and let's try generating again. Okay, yes, that looks better, except there's still an error. What is it now? Seeded gen. I have the wrong sizes of tensors. I wonder if I'm getting the wrong seed here. Well, I mean, there's only one way to find out. We are going to do some print debugging again. Oops. Okay. But we need to open up. Okay. And let's see where this is happening. It's happening here. Line 986. Okay. So basically, I'm just going to figure out whether it's this or the other thing, which is causing me problems. Actually, this tells me, right? Line 986, oops, is this. So it's the source that's a problem. Basically, this tensor is the wrong shape. Interesting. Did I have an extra processing step that would change the shape of this? So inside, you know, all of this data is like some kind of array, like basically a giant table, right? But the shape of this table is a little wrong. So, I mean, there is a way I can find out what's going on. If I go into results, it's so frustrating, you know. I thought I was really close to getting this, but of course I'm not. Now that I think about it, there must have been an extra processing step that I used. Yeah, there was. Okay, I remember now. Because this is not all that happened. Somewhere in here, there's like an extra hidden step. Right here. And I'm missing that step. So, and I think I remember this was a resizing step, because something about this model was a little different, if I remember. Actually, maybe not. Okay, you know what? There's only one way to find out. I'm going to actually open up that spectrogram and take a look at what's in it. Right. Okay, I already moved it out of there, so I can't look at it there, but I can look at it here. Okay, we're going to go check out datasets, test B. Oh, sorry. Okay, there we go. Okay, that's the thing we have. And we are just going to open it up. So I've just opened up Python, so I can just manually type in some commands. And let's see, torch.load. Just gotta take a look at it. Yeah, so it is the wrong shape, right? It's 160 by 647. And what we want over here, something that has 1, 2, 3. Wow. And then, okay. So it looks like I just need a couple extra dimensions and it will be good to go. Although I'm really suspicious of this. Okay, well, we'll just try it. We're just going to save this. So A equals how many dimensions do we need? 1, 2, 3, 4. 4 dimensions, so I need 2 extra ones, and then everything else is the same. Okay, and we're going to save this. It's open somewhere. Okay, oh, I'll just save it somewhere else. Okay. Oops, I accidentally closed that. Okay. Data set. Gosh, I don't know how I get anything done like this. Let's take a look here. Chorus 1. Okay, we are going to just in case, I'm going to keep this. Okay. And let's try running this again. So it should be the right shape at least. Still an error. So it's trying to pad this image because it thinks it's an image, and something is going wrong here. Okay, you know what? I'm going to open something that works, that I know works, like this guy. Unbelievable. Unbelievable. It's under dated results. So I'm just going to open something that I know has worked before. Okay, and that would be this seed image place. So I have this guy. I know it's loaded. I know it works. So I'm just going to open this up and take a look at what it is. Oh, right. Okay, there we go. Whew. So we're going to import torch again, load. Oops. What's it called? Seed underscore, not seed dash. Okay. So it's a completely empty tensor. So it's only got 3 dimensions. So maybe I have one too many dimensions. Yeah. Okay. Okay. Well, let's just go back and make it one less dimension. Man, so much work. Okay. Where is this? Yeah. Okay. Then. And it's test B. Okay. And we're just going to so this is just getting. This is so tedious. It's just getting the data into the right shape. Okay. Wait, where did I put it? Oh, here. Okay. So I just need to move it back. Okay. And then let's run it again. And see if it works. It still doesn't work. Oh. Okay, what's going on? I think it's the seed. The seed is probably screwed up. That's my guess. I'm just going to copy what I have into the seed and then we'll go from there. Or I can find the seed that I had, which was working from a while ago. No, this is source though. It's still a source, that's the issue. Oh. Unbelievable. Need some relaxing jazz. See, part of me says, you know, it's just some silly errors, let's just call it. But, you know, I also really want to get this working. It's so close. It's like so close. Holy crap. Okay. Come on. Expanded size of the tensor match. Let's take a look at a different one that I know works. Ah, yes, I do have something that works. Okay. Okay. Load. This time we are going to load training sample. Oops. I mean, that's fine, right? Okay, so maybe it is. Maybe it's the seed that is working. Okay. Let's change the seed. Seed audio, where is it? Okay, so I'm just gonna open up disk internals. Going all the way back. All the way back. So this is back into my my Linux file system, and it should be under results. Seed image, right? Yeah, see, this one's a lot bigger, right? So I think what happened was I overwrote this with something. So even if this doesn't work, at least I'll have a better starting point for this seed. Okay, so I just need to copy it back. Okay. Actually, sorry, I want to check that again. Right? So we're just going to we're just going to run this just to see what the seed image looks like. Oh shoot, this is Windows. Okay, yeah, see, this is the correct seed size, right? Okay, so maybe it was a seed problem. Okay. I'm still having an issue here. Oh, you know, it's probably because I changed it. Oops. So I'm just going to, let's see, I'm just going to, right, so it's because I changed the shape of this guy, right? So I'm just gonna move it back. I'm just gonna switch it back. Let's do a shot. Still having this error. Holy crap. It's crazy that it was fine. Slowly dying over here. That's how this goes. Yeah, so it automatically creates those extra. Oops. Back to print debugging. Okay, so it's kind of suspicious, right? The 0 here. So I think that's an issue. Ah, I forgot to copy over the seed, that's why. Silly me. I fixed it. I just forgot to fix the fix. Okay, so... Wait, no I did. What? How can the seed have 0 shape unless it's not empty? It's not empty. I mean, there's something in this image, right? What? What? What is going on? Okay. Take a closer look at the code here. So where does it get the seed image from? Pulls it from the source. Ah. Oh, okay, I understand what's going on. So it picks a position, and the thing is, I hard-coded this position because I was in a rush, and it must not be able to find this position because this file is too short compared to the original one. So that's fine. I'm just gonna set it to something like 0, right? So I'm just gonna duplicate this line. Not that it really matters at this point, but yeah. Okay, that was very confusing. Yeah, sure. Let's. I mean, these are in terms of the spectrogram resolution, which is like probably about 200 samples per minute, somewhere around that. Sorry, per second, right? So 0 would be right at the start, and this is apparently at 0:59, so 59 seconds. So it looks like it's about 100 samples per second. So if I move it to like 1 second, let's try it from there. Okay, and it's just picking a spot right in this as the seed. That's what that's doing. Okay, well, I think I fixed it then. Okay, let's try it again. Yes! Okay, it's generating. Oh, I was this close to quitting there. You know, you can be smart or you can be persistent, and right now I am persistent but not smart. So let's close this. Actually, I'll keep it open just in case. Just in case. Okay, it's going to generate a bunch of samples, but I'm in a hurry, so I'm just gonna skip right ahead to turning this back into audio. So if we go here, turns out there was nothing there. That was just my imagination. We did this, we did that, and now we just need to do this. All right, so we're going to use WaveGlow to turn this back into audio. Yeah, okay. Great. So, let's see. So this is still my Docker container up top, but I do need the data in. So right now, the data should be under presentation. Let's make sure that's correct. Yeah, those are being created at midnight, you can see, right? So the midnight ones are the ones I want. Since I don't really have a good way to copy them out. Let's just copy the lot of them, I guess. I mean, I can't really run both models simultaneously anyway. I probably don't have the GPU memory for these. So the way these work is the GPU memory is what constrains the size of your model. And for the really big models, people use like multiple GPUs to train them, right? But in my case, I have a consumer grade GPU. So like the ones you can get for data centers have something like 32 gigabytes of memory, GPU memory. And yeah, I have like 11, which is already a lot. Like I think my laptop has like maybe 1 gigabyte of VRAM, so GPU memory. Yeah, so anyway, it looks like it finished, so that's good. Just take a look. Yes, it did finish. Okay, there's a couple it didn't do because I think, yeah, I think those checkpoints were missing, but it's enough. It's good enough. So time to move this and get it done with. So yeah, like I said, not enough GPU memory to run everything at once. So now that the generation's done, we can get rid of that. And we just need to move all of these files over. So over to something that the Docker has access to, which should be under here, right? Yes. I believe I stuck it in info. Oh. Why isn't it letting me move there? Well, I guess I can do it this way. So I'm just using Windows Explorer to do this because I am tired of this. Okay. Torch. Speech. Oops. Tron. Okay. I need permission. What? Well, I mean, sometimes you just need brute force. That's what you need. Okay. Okay, and we're going to remove that. Remember, that was the test file that I used to generate. Okay, I don't really want to generate these because these are the old ones. So, yeah, you know what? Who cares? Who cares? Let's just get it going. So, it's infer, right? Okay, do your thing. I mean, I think it's running. It's just gonna take a little bit. So the model's spinning up probably. Uh-oh. Ah, right. Okay, this is the missing processing step I was talking about. So, let's see. It only works on 80 channels at a time. So, really, does it only work on 80 channels? I guess it only does. Wow, that's tiny. So I think I had to downsample all of these, and I had a script for doing this. Wow. Okay. Well, there's nothing to it but to do it, I guess. So first of all, let's add in a little box here. Missing bit, missing link is downsample. Okay, time to go hunting for more scripts that I wrote once upon a time. Let's just split out another window, I think. Yeah, okay. So it should be under, like, here somewhere. Actually, I don't trust this, because the files here are probably older, so I'm just gonna jump in here. Okay. Let's see. Resample, yes, that's the part I'm missing. So, wait, no, this is for the WAV files. Okay, that's not what I want. That's also not what I want. This is probably the one. Okay, this creates images. So at one point I wanted to debug these spectrographs. So this will turn one of those spectrograms into a picture. But does it downsample it? I don't think it does. Does it? Maybe not. Okay, let's take a look here again. I never got that far, apparently. Well, that's unfortunate. Okay, time to dig into my original Linux install again. Because I know it's somewhere in here. Let's see. It's probably here, right? Yeah, it is. Here it is. This is the one. Okay, so I keep forgetting that there are other pieces of this puzzle. You see how messy this whole project was, but let's do it. Let's save it out. No symbolic links. Okay. And let's go get them. So I'm just using Windows Explorer because it's in my... Okay, here it is. Okay, we got it. Okay, we're back in business. So, I just copied over this. I believe this is what I used. So we have this little guy and this. Okay, so let's take a look at this first. What is that? Okay, this is clearly not related. Wow. Let's see what's around here first. Okay, I got the totally wrong thing apparently. Let's try that again. Oh, I'm so close I can smell it. Was it in here? Ah, it was in here. Okay. Converted. Yeah, I remember this. Okay, so I was converting things in order to get them to the right size. I just don't remember which file I used to run the convert. Oh, this one. Convert CH. Okay, that's the one I want. So that should already be on here. Okay, let's see, convert. It's apparently not here. Okay, so I'm just missing a bit. That's why. Okay. Okay, that's fine. That is fine. At least I know what the issue is. Okay. Done. Almost ran something I didn't want to run there. So we can get rid of that because that was the wrong thing. Now we're going to bring in the right thing. Okay. Yeah, that's the one here. Okay, so there's multiple copies of the same things floating around because some of them are more recent than others. And this time we want, where is it? Convert this guy. How many shell scripts do I have? Resample, voice detector, wave to mail. So none of these shell scripts matter. So what matters is this guy, I think. Yes, okay. So for every file in this directory, outputs, it's going to output something to out there, which is it loads the spectrogram and then it transforms it, and then it also saves an image out. That's nice. We can look at our audio as an image. Nice. Okay, and then it'll save it to converted. Cool. So I think we just need to run convert. So we actually need to copy our images back because we stuck them over here, right? Yeah, we stuck them over here. So we actually need to move them back. Whew. Whew. Okay. Should be. Move all of these. Well, actually, let's take a look here. Make sure I'm moving the right things. Yes, those are the right things. So we're going to move all of those to outputs. But before we do, let's make sure there's nothing in outputs. Yeah, there's already something in outputs, right? Yeah. Okay, so we're gonna just remove everything in outputs. And let's see if there's any converted stuff. Yeah, there's loads. Right. So let's just remove again everything because I've already got a copy elsewhere. Okay, great. Now we can actually move everything. Oh. Okay. Let's just make sure those are the new ones, not the old ones. Yep, they're all created midnight. So now we are going to we're going to run that thing. So hopefully it works. Looks like it works. Let's take a look. So here's the converted stuff. Hey, okay, so that kind of looks about right? So this is what the spectrogram actually looks like, except I think it's upside down. So the top is like the highest, lowest frequencies, and the bottom is the highest, right? Okay, it looks pretty short, so it looks about right for what I was generating. And there's a whole bunch. Some of them are resized, some of them are the originals, because remember I had to rescale this to make it fit. Because the WaveGlow model only has 80 channels. That's the problem. So here we have downsample from 160 to 80 channels. That's why. Right, so you can think of it as like there's only 80 frequency bands in the input to this WaveGlow model. And so I have to downsize it. Now that that's done, we can move the converted stuff. So everything in here, which is a mel, yeah, and we're gonna move all of those back. So let's do that. We're just doing the opposite, basically. We're going to move everything in output, well, converted to WaveGlow full clone data infer. Yes, okay. And let's try running our good old inference script again. This should be it. This should be the last step. Yes. Okay, no errors. So here, oops, I'm just gonna bring this to the front. So you can see that, let's see, got through the downsampling part, and now we're finally at the generating spectrograph part, and looks like it's working. So if we look on the output side, it should be generating these very shortly. So we gotta wait a bit because there's quite a few chunks to go through, but very soon I expect we will see something nice, and very soon. Just like, I'm just going to spam this until I see a file show up. Oh, wow. That was quite the adventure, I gotta say. I did not expect it to take 4.5 hours, but at the same time, I did have this much time available. So clearly, you know, work just exists to fill the time you have, I think. So we have finished everything here. Do not have enough time to go over the original presentation I gave on this project. It was pretty funny. I actually pre-recorded myself having a dialogue as if I was like talking with Leonard Cohen, It's pretty funny. I enjoyed it. So, yeah, while we're waiting, let's see if it's done anything. Yeah, there. Hey, there's some stuff. Okay, so let's take a look at these files. Hopefully they're the ones that I want. I can't open them this way, can I? Nope, I gotta copy them back. Okay, that's fine. We will do that. We'll just copy it out to here. Yeah, okay. Okay, yeah, these are good. These are the short ones. So let's take a listen, and hopefully, this is good. Wow, that's very quiet, but I think... Okay, I'm going to open it up in Audacity so that I can increase the volume a bit if necessary. Okay, so good news, it's the same length as the original recording. So the top one's the thing I recorded, right? So if I play that, testing, 1, 2, 3, right? Okay, now let's try playing this. Testing, 1, 2, 3. Oh, I feel like a mad scientist. Okay, so it's very quiet. Probably needs to be normalized. But okay, this might be a little too loud, so I'm gonna turn it down a bit first. Testing, 1, 2, 3. Yeah, okay. There you go. Testing, 1, 2, 3. Okay, nice. Hello, and welcome to the average expecting. Hello, and okay, the last part got cut off. Yeah, the last part got cut off, but it does work kind of. It's kind of like if you took my voice and kind of made it sound a little bit off. Like, it's not quite that good. But it does have a little bit of that Leonard Cohen voice, just a hair of that flavor. Testing, 1, 2, 3. Hello, and welcome to the average expecting. Okay, so I mean, the thing is, in order to actually, produce a semi-convincing deepfake, I basically ran this on multiple checkpoints, right? So let's just try a different checkpoint and see if it sounds any better. So we're going to just select all of this. Control R. Normalize. Turn it down here. Testing, 1, 2, 3. Hello, and welcome to the average expecting. Yeah, that one sounds a lot better, actually. I like that. Hello, and welcome to the average expecting. It's so gravelly right here. And welcome to the average. Yeah, and welcome to the average. Okay, it's still getting cut off at the end. I'm not sure if that's like an artifact or something, but it's working, and that's what's important here. Okay, I'm gonna see if there's any more that have been generated since then. Yeah, there's a couple more. I don't know which one's which. So 407 I've already got, 414 I've already got, so these two are new. Let's normalize those. Testing, 1, 2, 3. Hello, and welcome to the average expecting. It's okay. How about this one? Testing, 1, 2, 3. Hello, and welcome to the average expecting. I gotta say, so far this one's the best. Testing, 1, 2, 3. Hello, and welcome to the average expecting. Yeah, I like the sound of this the most, I think. So, I mean, we're not done yet. Yeah, it's still generating stuff, so let's see if there's any more. Yeah, so these don't count because those are some of the leftovers from the past. Whew, I mean, mission success, right? Let's see. We finished. Okay, let me go through the list of what we did and what we didn't do. So, test audio, got that. Moderation, got that. Got things running. That's the important thing. Present all the things. We did not need to do the backup plan, although things got a little dicey at some points. A lot of bugs, a lot of things I forgot, but I'd say that's a success. So yeah, I think that's it. You know, I'm just going to close out the stream maybe with the song that we ended up producing from this. And that was like after generating loads of samples like this and just piecing together the best ones. That's all we did. Let's see, so it looks like it generated another one. I want to listen to a few more just to see if I get a slightly better one. Yeah, so there's a new one here somewhere. Okay. Did 407, 408. 408's the new one.
Testing. 1, 2, 3. Hello, and welcome to the Average Expectation.
And it's not that great. No, still like this one the most. Okay, well, yeah, I'm just gonna let the rest of this run, but let's put on the music. So it's actually on Bandcamp. Thanks again. Shout out to my brother for doing that. Let's take a look. All right, so that's it. Thank you all for coming to the stream and all that. I mean, it's just a test stream, but well, next Friday, starting for real. It's Friday at 8 p.m. So see you then. And we'll just, you know what? Is there a nice ending? Can I use this? Yeah, I'll just use this screen. Okay.
Shepherd